fosters creativity and innovation. If we all embrace the spirit that there really is no limit, if we rise to this occasion and come together across nations, if we integrate and ideate, we can make the future great and live the dream. Our legacy of education takes its root from our founding father, late Shri Dayanand Sagar, a visionary, an educationist, a powerhouse of knowledge and a believer in transforming the world, besides a leader par excellence. The institution has contributed to educating the world for over 60 years, carefully building alumni of over 100,000, including accomplished professionals, sports personalities, celebrities spread across the globe. We stand strong as a top-rated university, having 4 campuses with 350 teaching staff, educating 4,400 students with pride-filled and powerful alumni network across the globe. Dedicated faculty members who work across disciplines, collaborating and lifting us as the top university in the world, empowering the rising generation and nurturing entrepreneurs. Dayanand Sagar University. Live the dream.
Good evening, students. So today again we are here with a new day. So today we thought of taking a physics lecture for PUC 2 syllabus. So students, maintain the decorum, study well. Sir is joining in a few minutes. There has been some network issue. So don't leave the lecture. We have the class till 8 o'clock. And the topics I have already told. You guys know the topics, right? I think everyone is today is not so active. You had more of the lunch or what? No one is speaking anything, raising hands, no questions, no QA. Oh, everyone is started raising their hand. Okay. I get to know that you guys are very active. Yeah, Ranjana, I'll be sharing all the links in the chat box. Please be in the session. Don't worry about that. Let the lecture begin and I'll share the links for the recorded session for yesterday, the joining link for daily joining link of the session of Zoom meeting, and your WhatsApp joining link. So please be in the session. Don't leave. Yes, Kavana and Sanjana, you have any questions, you can send in the chat box. As I see, you guys are raising your hands from so long. Okay. Okay, so students, I hope yesterday's class was very good for you guys. And what about the questions which you got which I have sent in the group, and the notes were proper for you guys, or you need some more? I'll ask sir about that. Okay, Yuvraj says yes. Okay. All right. So the notes are proper, it means no one is saying anything. So yeah. Also today's sessions are on PUC2. I hope you guys know the topics, right? Who doesn't know? Who doesn't know? The topics are electric field, electric potential, and capacitor. You're welcome, Yuvraj. Yes, Kiran, you have any doubt, you can send in the chat QA box. I see less number of students today. What happened? Your friends and classmates are not active today. What happened? They are not joining the session. Please share it to your friends and classmates also, so that they could also be able to learn some new techniques and some new expertise, so that they can score good marks in their CET exams. Or you guys don't want your friends to come first and come score good marks than you, is it? Video not visible, sir. I don't on my video. That's it. Today, don't worry, Shurbi. Today, the weekly schedule will be shared with you before end of this session. Don't worry about that. Weekly schedule including the professor's name, subject, and what the topics they are going to cover. So you need not worry about that. You'll get to know. So today it's physics. Tomorrow it will be chemistry. Okay. Yes, daily from 4 p.m. to 8 p.m. So now I'll hand over it to Manjunath sir. Sir is here with us. Sir will start the session. Good evening, sir. Manjunath sir, am I audible, sir? Hemant sir, can you please give permissions to Manjunath sir?
Nikesh, it has given.
Sir, co-host.
Done.
Okay. Yes. Yeah, Manjunath sir, you can hear me?
Nikesh, can you check with the professor?
Yes, sir. I'm calling sir itself.
So from my side is it audible, sir? Yes, sir. Yes, sir. Thank you.
Yes.
Shall I go ahead, sir?
Yes, sir. Sir, we can go ahead with the session. So students are also waiting from, it's been 12 minutes. We are late. So let's
Yes.
start with the session now. Students, I'll be handing over it to Manjunath, sir. Sir, please carry forward.
Hello, good morning, students. Good evening, students. I am Manjunath, faculty in physics. Okay, I used to take up class on electrostatics today. Okay, so I will present the screen and then we'll discuss more things regarding this. Let me present the screen. Okay, so only 1 second. Uh, sir, sorry, sir, how to present the screen, sir? Here we don't have
Sir,
finding the options.
sir, share screen. You can go and you can directly
Share
present.
screen, huh?
Yes, sir.
Yes, sir. Yes, sir. Okay. Double click, sir.
Yes, sir.
Yes. Huh. Okay. Yes, sir. Okay, sir. Okay, sir. Thank you, sir. Okay. Hi, students. Let us go back to our this discussion on CET concepts on is, electric charges and fields. In this electric charges and fields, what are the points that are to be noted before going into the actual problems? Is that first we are going to discuss about. Okay, first we will discuss about uh, charges. What is meant by charge here is charge means it's the fundamental property of the given material. Okay, fundamental property. It's just nothing but a fundamental property, just like mass, length, okay, but dimensions like area, and so for a given material, this is also one property that is to be defined in order to have a complete information regarding that uh, particular object. So these charges are going to be studied under the heading what we call it as electrostatics. Charges at rest. Okay, electrostatics is a branch deals with charges at rest or steady. Okay, under the heading of what is known as electrostatics. So in this, we'll take up the concept of electric charges and fields. Under that, first we need to know some properties of charges. As you know that charges, okay, attract if they are like, okay, if they are unlike, unlike charges attract, okay, charges will repel if they are like. Okay, so this is one of the property, and one more most important character is that our property is that charges are conserved. charges are conserved. What is conservation of charge? Charge of any body can be written as the integral multiples of fundamental charges. N can take values starting from 1, 2, 3, so on. Integral multiple means half integral multiples are not allowed. That's what the meaning of integral multiple of charge. Charge of any body, that is Q, can be written as the integral multiple of fundamental charge. Okay, as we already discussed, these charges attracts when they are unlike. The charges will repel if they are like. The force of attraction or repulsion between them is directly proportional to product of the charges and inversely proportional to square of distance between them. This law itself is called Coulombs inverse square law. Coulombs inverse square law in electrostatics. Or if we remove the proportionality sign, we have to introduce constant 1 by 4 pi epsilon naught q1 q2 by r square, where 1 by 4 pi epsilon naught, its value is found to be 9 into 10 power 9. This is the case when we have two charges separated by a distance of r in air or vacuum. Okay, air or vacuum will be the material that in between. Okay, if let's say the whole system is immersed in certain, let's say this is q1 charge, same q2 charges, and distance of separation is r. Okay, if it is immersed in a medium of dielectric constant k, force between them is going to be given by 1 by 4 pi epsilon naught into k q1 q2 by r square. That is, okay, force between the charges decreases by k times. Okay, due to, that means due to presence of dielectric, okay, force between charges decreases. Force between charges decreases by k times. Okay, it decreases by k times. And if suppose, let's say the same two charges q1 and q2 separated by a distance of r, no doubt, in between them, and if a portion of it, okay, is filled with a dielectric medium portion, not completely, and its constant is k, then force between them becomes equals to 1 by 4 pi epsilon naught q1 q2 by d minus t plus t root k whole square. This is the most general formula to find force between the charges. Okay, this is what Coulomb's law. And then we will say, we will define what is known as the electric field as, okay, this is, we are going to get the expression as 1 by 4 pi epsilon naught q by r square. It is the force experienced by unit positive charge. Force experienced by unit positive charge, we call it as electric field. Okay, this is called electric field. And it's found to be equals to 1 by 4 pi epsilon naught q by r square, and it is measured in, okay, Newton per Coulomb, or electric field is nothing but 1 by 4 pi epsilon naught q by r square, or this is equal to F by Q, and it is measured in Newton per meter. So this is what electric field is. So now if we consider a dipole, let's say if you have a dipole means equal and opposite charges separated by some distance. This is called the axial line, and this line is going to be called as an equatorial line. Equatorial line. Here, okay, this electric field will be in this particular direction. Equatorial line, that's given by 1 by 4 pi epsilon naught p by r cube. Okay, p will be dipole moment. This is nothing but dipole moment. P is nothing but dipole moment, and it's a vector from negative to positive, we will get. And electric field along the axial line is given by 1 by 4 pi epsilon naught 2p by RQ. Okay, here electric dipole moment will be in this particular direction. So once again from the above we can conclude that electric field along axial line is twice the electric field along the equatorial line at the same distance. Okay, so this is what electric field because of due to what is known as a dipole. Okay, after that there will be a Gauss theorem. Before Gauss theorem, you have to define what is known as electric field lines. Electric field lines. Electric field lines always starts from positive and end over negative. It will start from positive and end over negative. No two electric lines. No two electric lines cross each other. No two electric lines will cross each other, and okay, the electric lines won't penetrate inside the conductor. Okay, or to penetrate inside the conductor, they will not pass through the conductor. That's what the meaning. Okay, these electric lines passing through any area normal to the surface, okay, is called flux. This is the flux, number of electric lines passing through given area normal to the surface. Okay, and the electric field is going to be given by this flux per unit area is nothing but electric field. Okay, this is also one of the definition of an electric field. Okay, and we'll have other definitions corresponds to electric field is that, okay, uh, one is force acting on unit positive charge, and second definition is number of electric lines passing through given unit area normal to the surface. So based on this electric flux, we will define what is known as Gauss theorem. Gauss theorem means electrostatics. What actually it states is net outward flux from any closed surface is equal to 1 by epsilon naught times charge enclosed by the surface. Okay, for example, if a surface encloses positive and negative charge minus q plus q separated by some distance, okay, this represents a dipole. If we consider a Gaussian surface, okay, which contains the dipole, then electric flux through this will be equal to 0. Okay, so that's what the Gauss theorem said. Gauss theorem what actually states is net outward flux, net outward electric flux from any closed surface is equal to 1 by epsilon naught times charge enclosed in it. Charge enclosed in it. This is called Gauss theorem in electrostatics. Here, you need to know certain aspects related to sphere. If you have a sphere, if you want to find electric field due to the sphere, okay, you'll get the graph which looks like this. See here, this is the graph showing, okay, this is the graph showing variation of electric field with the distance. So here electric field will be 0 inside and outside it becomes maximum. Okay, this is what small r equals to capital R. Whereas potential is not like that. Potential will be constant when V is constant. Okay, after that it goes on decreases also. Okay, this is the variation of potential, okay, and electric field here for a sphere. So if you want to write down the equations, inside it is 0, on surface 1 by 4 pi epsilon naught q by r square. Okay, and outside the surface 1 by 4 pi epsilon naught q by r square. Okay, here maybe we can write down capital R square because it is radius over the surface. Outside it goes on decreases. Okay, this is the variation of electric field and potential occurs for a sphere. And in the same way, okay, if we consider an infinite line of charge, if I want to find out electric field, okay, at that particular point, okay, this particular electric field will be in this direction. Okay, this electric field is found to be equals to 1 by 2 pi lambda into 2 lambda by r. Okay, so this is what, okay, sorry, 2 lambda by r, 2 pi epsilon naught, 2 lambda by, if it is 2 there, it will be 4 here. 1 by 4 pi epsilon lambda, epsilon to 2 lambda by r, where lambda is charge density. Okay, na? Linear charge density, r is the distance. R is the distance and the lambda linear charge density. So this is what the electric field due to infinite line of charge. And once again, electric field due to sheet of charges. No, this is for sheet of charges. Okay, electric field is going to be given by sigma by 2 epsilon naught. Okay, sigma is nothing but surface charge density. Surface charge density. Okay, this is nothing but surface charge density. Let's say, let me write down clearly, that is surface charge density. Okay, right. These are the points that are to be remembered in order to understand the concept of what is known as electric fields. Okay, let's go to the directly the problems involved here. So go to the problem. So we will certainly do some problems, and we will try to explain as simple as possible. Okay, and learn it. So an electron from rest through a vertical distance h in a uniform and vertically upward electric field E. Meaning is, here we are releasing an electron in a uniform electric field, upward electric field E. Let's say this is the upward electric field E. Okay, na? So an electron falls from rest. An electron is here. Its initial velocity is 0 because it is falls from rest. Okay, directed upward. So if it is directed upward, here we have a positive charge, somewhere here negative charge, it will move down. Okay, it will move down like this. The direction of electric field is now reversed. Now electric field is reversed like this. When it is reversed, magnitude is remaining the same. Here also E will be the magnitude. Proton is allowed to fall from rest through it. Proton is allowed. If it is proton, is positive charge here, negative charge is here. If the proton is released, okay, proton is released, it will always move from higher potential to lower potential, moves down, okay, moves down for a height of h. For a height of h, the time taken time of fall of electron in comparison to the time of fall of proton. Now what is to be determined is which one will have smaller time in order to reach the height of h downward. Okay, whether it is for electron or whether it is for proton, we need to find out. See here, when a charge enters, force acts on it. Force on an electron is given by E into E, that's equals to m into A. This is nothing but E into E, that's equals to m into A. Correct now? So this is mass of proton, this is mass of an electron. So acceleration is going to be given by E into E by M. Acceleration, if you want to go to acceleration, A equals to E into E by M into A. Sorry, M into P proton. So you just go through it. Okay, displacement. Displacement is same for both the particles. Displacement is same for both particles. And so, S equals to ut plus half of et square. Okay, apply it for both the particles. For both particles, for electron here, for proton here. So this is H equals to 0 plus E into E by M of E into T square. H equals to 0 equal to 0 plus or minus E into K M P into T square. So equate them. Okay, this is time for electron, this is time for proton. Okay, na? Now get the value of this. If this is the case, time required is going to be gone by me into h by e into e. Okay, me into h, me into h by e into e. So that means h, e, and e are very okay. Here h, e, and e are same for both proton and electron. Hence time depends mainly on mass of the particle. Time for mass of the particle, that is electron, is greater than, sorry, electron mass of the electron is less than mass of proton. Hence time taken will be more for silicon silicon than any other element. Okay, so from this what I can conclude is, see, go through this. Okay, here it is given mass of, if the mass of the particle is more, then time taken by the particle will also be more. See, time is proportional to root m. Mass of electron is less than mass of proton. Hence, okay, the electron takes less time to travel through the given field. Okay, that's why this option
Okay,
A
sir.
will. Okay, one or two questions will be lengthy, of course, but other simple questions will be very simple. See, what
Surely,
I
sir.
did is, okay, what I did is, we allowed the electron and proton to enter the magnetic electric field. I just calculated time. Time found to be proportional to mass, square root of mass. As mass of electron is less, it takes less time. That's it. Okay, go for next problem here. Here we see, this is the problem appeared in 2017 NEET exam. But understanding, once if you understand the problem will be very simple. Suppose here it is given that, okay, yeah, as we know that in an atom, electron charge is equal to proton charge, but opposite in nature. Here see, suppose charge of proton and electron differs slightly differs. One of them is minus E and other is E plus delta E. If the net electrostatic force and gravitational force between two hydrogen atoms placed at a distance d much greater than atomic size apart is 0, then delta E is of the order of, meaning is CF. We have two hydrogen atoms. Remember that we will have two hydrogen atoms. Hydrogen atom will have a proton. Proton will have this much of charge. E plus delta E and electron will have del minus E. So what is the net charge of this? Net charge of this will be delta E. And like that, we will have another one, E plus delta E, and another one electron. Okay, net charge of this is delta E only, no doubt. They are kept separated by a distance of d between them. So they repel. No doubt they will repel each other with the electrostatic force. No doubt in it. Whereas they are also attracting, no, because of due to gravitational force. This is F due to gravity. Okay, this is what happening. Why they are repelling? Because each atom will have a extra charge of delta E. Why they are attracting? Okay, because of due to gravitational force of attraction. If there is any, if we have any two masses which are kept separated by some distance, between them there will be a gravitational force of attraction. They are cancels out. Meaning is net force on each one will be zero, means Fg is equal to Fe. If this is the case, what is this delta E they are asking? So we know that gravitational force is given by G into mass of proton into mass of proton divided by distance square. That's equals to 1 by 4 pi epsilon naught. Okay, charge into charge divided by d square. D square cancels out here. What remains? You just substitute here, whatever it is given. So if it is substituted, this will be 6.6 into 10 power minus 11. Mass of proton is how much? 1.67 into 10 power minus 27 square it. That's equals to 9 into 10 power 9 into, okay, delta into delta E square. Okay, this is what we need to find out. Okay, so now you just, here see, once you go through the options, only powers are given. So calculate only the powers by leaving the numbers. Delta E square equals to, here you see 6.6, keep it as it is, 1.67 aside, 10 power minus 11 into 10 power minus 54 whole divided by, okay, of course 1.67 also will have a square, okay, 1.67 square, and this is 9 into 10 power 9. So let us take care of this, and this cancels out. This is going to become 10 power minus, okay, this will be 11, okay, this is going to become minus 11 minus 9 minus 20 into 10 power, okay, minus 54, okay, minus 54. Okay, this is what happens. Okay, then this is going to become delta E square. No, delta E square will be equals to 10 power minus 74, or delta E will be equals to 10 power minus 37 coulomb. Okay, hence the option is, okay, 10 power minus 37. B option is the correct choice. So here what I observed is, okay, the each hydrogen atom will have an extra charge of delta E that is to be determined, and it is given the condition that they are kept separated such that, okay, gravitational force of attraction is equal to electrostatic force of repulsion. Just use that and simplify only the powers. You will end up with 10 power minus 37 coulomb. Okay, thank you. Next one, we'll move on to the next problem. Here it is. This is also a little bit a tricky problem only, but this is not tricky, but not difficult, too difficult. So go through the problem once. It is given that, okay, we'll have two identical metal spheres, okay, suspended from common point by massless, okay, strings of length L. Let's assume that these are the two identical spheres. Okay, two identical spheres are two identical charged spheres suspended. Okay, its length is L. Are initially at a distance d apart because of their mutual repulsion. Because of due to the repulsion, they are getting separated like this. They got separated like this. This will repel this with a force of Fe. This will repel this with a force of Fe. Okay, na? The electrostatic force. It will have charge of Q, of course. So the charges begins to leak from both the spheres at a constant rate. Okay, the leakage of charges will be at a constant rate. As a result, spheres will approach with a velocity of v. It is proportional to distance x as. So go through it. Whenever the spheres repel from one another, okay, they will make some angle with the vertical, or okay, there will be a gravitational force which is acting exactly in the downward direction. Okay, Fe electrostatic force which is on the opposite directions, and one more tension acts in between these two forces. So if this is theta, this will also be theta. Okay, then it will be T cos theta, T sin theta along negative axis. Okay, this is in the same way. These are separated by distance of x. X is the distance of separation between these two spheres. Okay. Now, at equilibrium, okay, what will happen? Okay, this becomes T sin theta. Okay, T sin theta will be in this direction. This will be fx. Okay, they're not this. This we don't have. Okay, right. So this will be okay. From the figure at equilibrium, T sin theta will be equals to Fe, that's equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. So that means I'm okay. Once for all, I'm substituting. That's all. It is not R square. This is X square. Okay, here Q1 equals to Q2. That's equals to Q. So T sin theta will be equals to T sin theta, or 1 by sin theta into Q square by X square. Okay, this is electrostatic force, and T cos theta will be equals to mg. Okay, T cos theta will be equals to mg, so that okay, I can get the value of tan theta as okay, 1 by 2 gives you tan theta. 1 by 2 definitely gives you tan of 2 theta. Tan 2 theta is nothing but sin theta by cos theta. Q square by sin theta into x square. What about this? M into G. Okay, TT gets cancelled. So we go through it now. As theta is small, 2 theta, okay, is going to be given by x by 2 by okay L. So this is going to become okay theta. Here theta or x will be equals to okay theta will be equals to x by 4L. Okay, now you substitute that. Here tan theta is almost equals to theta, or 2 theta will be equals to x by 2L equals to q square by x square into mg into sin theta. Okay, mg into sin theta. Now we go through it. Q, k, and x. So this implies q square is proportional to x cube. All other things are constants. All others except x and q are constant. Okay, so now q is proportional to x to the power of 3 by 2 dq by dt. It's given that it's a constant. That's equals to 3 by 2. Okay, x to the power of half into dx by dt. Na? Okay, this implies x to the power of half into v equals to some constant, or velocity with which charges discharges is proportional to x to the power of minus half. Okay, so velocity with which charges discharge is directly proportional to x to the power of half minus half, where it is x to the velocity of charge distribution is directly proportional to x to the power of minus half. This is how this problem is going to be done. Next, go to the next question. Okay, that is electric field in a certain region is acting outward is given by E equals to E into A. A charge contained in the specific radius A centered at the origin is given by. We need to find out charge. Electric field is given. We need to find out the charge. We know that net outward flux equals to 1 by epsilon times charge. So net outward flux is nothing but outward flux. Net outward flux from any closed surface is always equal to 1 by epsilon naught times charge enclosed by the Gaussian surface. Q we need to find out. Q equals to epsilon naught into epsilon naught into phi net electric field. Net means number of lines outgoing minus number of lines comes in. And it's given. E is given. Phi is nothing but epsilon naught E into A. Phi epsilon naught A. Area. Then the area of this, what is the area? Electric field at certain region is acting in radial outward. A charge contained in a small sphere of radius A centered at the origin of the field. So this becomes A into A. So electric field it is, and it's a sphere of radius A, 4 pi into A square. And that will be the radius of the sphere. So this becomes equals to Q equals to epsilon naught into A cube into 4 pi. So go to that. Epsilon naught A cube into 4 pi. 4 pi r square will be the radius of that particular sphere. So this is how you can able to get the expression for 4 pi epsilon naught A cube. Here we have the answer, 4 pi epsilon A into A cube. So very simple problem. Only thing is, what is charge? Charge is nothing but flux into area. This is one of the method of finding charges. Flux is E into E. Net outward flux is given by given by E into A. So substituting epsilon naught into E into A, we will get the required result 4 pi epsilon naught into A cube. Right. Next one is next question. Here, a hollow metal sphere of radius r is uniformly charged. In electric field, due to the sphere at a distance r from the center is electric field. We have already drawn the graphs. Electric field inside the sphere and up to the sphere it is 0. Above that small r equals to capital R, electric field is maximum. Outside it goes on decreases. Based on that you check the options. Increases R increases for R greater than less than R and R greater than R. 0 as increases R is very small compared to capital R, decreases as R increases for RP. Deaccelerates as R increases for R less than R and R greater than R. From the center, what happens? Electric field increases up to R less than R and increases for R greater than R. No, it won't increase like that. 0 as increases from R to decreases. Yes, this is correct. So that means electric field inside the hollow sphere is 0. That's already we have shown in the first page itself. See here, electric field inside the hollow sphere is this. inside the sphere is 0. On the surface as well as outside the surface is given by this relation. So, okay, then what is the next question? Next question will be when two parallel plate line charges of linear charge density lambda and minus lambda coulomb per second are placed at a distance of 2r from free space. What is the electric field at the midway in between the two charges? Midway. Okay, here see two parallel infinite line of charges with charge densities. It is given like this. Here we have infinite line of charges. Okay, infinite line of charges 2. Okay, minus lambda here plus lambda and minus lambda. Okay, coulomb per second. Okay, so what will be the electric field at the midway between the two charges? So what about electric field? What are the challenges you are going to face while making electric rails? So here what we are doing is we are considering a point P exactly at the midway. That means from here to here distance is d by 2. From here to here distance is d by 2. Okay, so now we have to find out electric field at the midway. Electric field at P due to plus P charges is 1 by 4. Okay, this is 1 by 4 pi epsilon naught. Okay, into Q. Q means lambda by, okay, lambda divided by what is the distance of separation? The distance of separation midpoint. That's why this is R. Plus 1 by 4 pi epsilon naught lambda by R. So this is going to become 1 by 2 pi lambda, 1 by 2 pi cancels out. Okay, na? Now what we are going to do is, we will get pi epsilon naught into R. Okay, na? Pi epsilon naught into R. So this becomes 1 second. Electric field due to a infinite line of charges is given by what? Is given by 1 by 4, so 4 root epsilon naught into what? 1 by 4 pi epsilon naught. Okay. See, electric field due to this at this point is given by this. E1 will be equals to 1 by 4 pi epsilon naught K into Q1 Q2 by d square. Similarly, electric field, okay, at a point P due to one more charge concentration is given by minus Q1 minus Q2 by R square. Okay. This is 4 pi epsilon naught Q1 Q2 by K. This is R square and R, where R is nothing but d by 2. R equals to d by 2. Okay. Then what you need to prove is these electric fields are in the same direction. Hence, net E will be equals to net electric field is equal to E1 plus E2. If it is added, 1 by 4 pi epsilon naught, 2 lambda by R you are going to get. Okay, here this can be written specifically as 1 by 4 pi epsilon naught, 2 lambda by R1, 1 by 4 pi epsilon naught, 2 lambda by R2. So this becomes, R1, R2. This is going to become, so this plus this is nothing but 4. Lambda 4 lambda by 4 pi epsilon naught, 1 lambda cancels. 1 4 cancels out. Lambda by pi epsilon naught into R. Lambda by pi epsilon naught into R. Pi epsilon naught into R. That is third option. You see. Only thing is you have to have the concept of the electric field due to infinite line of charges. Electric field due to infinite line of charges is given by 1 by 4 pi epsilon naught, 2 lambda by R. Okay, now by using the same we are trying to find okay, we are trying to find what is the electric field at different distances from the given line of charges. Next one, see here, this is also very important one. 2 point charges A and B having charges plus Q and minus Q. Plus Q and minus Q respectively are placed in that certain distance apart from electrostatic okay, and the force between them is F. Here force is F. If 125% of charge of A, sorry, 25% of charge is transferred to B, then B has to transfer 25% after 25% charges and becomes. See here what is given is if you have two charges separated by some distance, force is given by what? F equals to 1 by 4 pi epsilon naught Q1 Q2 by d square. Okay, then d is the distance between, okay, this particular case. So this is distance between the charges. Okay, distance between the charges is given by, okay, it is given by 1 by 4 pi epsilon Q1 Q2 by r square. Now what we are doing is 1.25 coulomb is added to charge of charge A is transferred to B. If 1 point, sorry, 0.25, if it is given out, 0.75 Q only, no, here you get only 50 volt. Okay, sorry. This becomes 1.57, 0.25 cancels out. Remaining is 0.5. So remaining is 0.5. See, one out of charge Q, if 25% is removed, 75% remains. Okay. Out of this Q, 25% is given. 25% plus 25% minus cancels out. Remaining is 0.5 only. Now F dash is equal to 1 by 4 pi epsilon naught 0.75 0.5 d, okay, d square divided by, okay, r square or d square. 1 by 4 pi epsilon naught 0.75 q, next to 0.5 q whole square. Okay, now f dash we calculate. F dash is nothing but 1 by 4 pi epsilon 1 by d square. What about this? 0.75 into 0.5. Okay, this is q square. Okay, 0.75 into 0.25. You are going to get here 0.75 into 0.5, 0.375. Okay. So R in here it is given in terms of fractions. In terms of fractions only, if I do, F becomes equals to some K into Q square by R square or D square. Here when fractions are given, F dash equals to K into 3 by 4 times Q. What about this? K, this is 0.5 Q by 2. Okay, sorry, different by d square. What happens to this? 0.5 means 3 by 8. 3 by 8, see 3, 1 by 2. This is 4, 3 by 8, f q square by d square. Q into q square by d square. So what happens? See 3 by 8. 3 by 8 we don't have, okay, 3 by 8 we don't have the option. This becomes 0.25% if it is removed, 75% is remaining. That's good. Part 3 by 4 times q, and 25% if it is added, 25%, okay, what happens? 25% neutralizes another 25%, remaining 0.5%. Okay, 5%. So this is 1 by 2. So 3 divided by 8 you will get. And distance between the force between the charges becomes A is transferred to B, force between the charges becomes, okay, this is 3 by 4, this becomes, okay, so F into Q square by D square, that means F becomes equal to 4 by 3 times F. Okay, this will be the correct option. Okay, next move on to the next one. Here you see a sphere encloses an electric dipole. Here, dipole. Remember that dipole containing plus q and minus q of charges, 3 into 10 power minus 6 coulomb. Another one is q2 is plus 3 into 10 power minus 6 coulomb minus. What is the total electric flux across this sphere? We know that total flux or net flux equal to 1 by epsilon times net charge. Net charge is equal to plus q plus of minus q, that's 0. That's why net flux will be equal to 0. That means if a surface encloses plus q and minus q charge, net outward flux will be equal to 0. That's why option 2 is the correct one. Next one, see. The electric field at a point on an equatorial plane at a distance r from the center of the dipole having a dipole moment P, okay, is given by. Okay, here we need to see the direction also. Sign always represents the direction. So we know that, okay, on an equatorial plane, see, this is plus q, this will be minus q, this is an equatorial line. So this is electric field due to plus q charge. This is electric field due to minus q charge. So resultant E net is going to be given by 1 by 4 pi epsilon naught 2p by r cube. So this is, but the electric movement will be from negative to positive. See, P is from negative to positive. Okay, so that's why it will be minus. Hence, option 4. 1 minus p by 4 pi epsilon. Okay, sorry. Equatorial plane. No, yes, equatorial plane. We won't get 2 in it. 2 we won't get. Okay, equatorial plane. If it is an actual plane, 2 we would have been written. Next one. Next, we'll move on to the acceleration of an electron due to mutual attraction between electron and proton when they are 1.6 angstrom apart. Let us assume that we will have an electron here and a proton here. Distance is 1.6 angstrom units. Okay, what is the force on electron? Okay, acceleration on an electron. Okay, here force of attraction between them, force on an electron is going to be given by 1 by 4 pi epsilon naught. Okay, E into P divided by, okay, d square, distance. See, electrostatic force, okay, we know that this is the mutual force of attraction. Okay, electrostatic force is mutual force. But, okay, we can also find force on each mass. Okay, so here you substitute that, okay, force on each mass. This is Fe, force on electron is given by mass into acceleration, that's equals to 9 into 10 power 9 into charge of a mass of an electron, that's 1.6 into 10 power minus, okay, 1.67 into 10 power minus 27, okay, into mass of electron is electrostatic force, no, that's nothing but minus 19, okay, into, okay, what is this, 1.67 mass, this, okay, this is 1.6 in 10 power minus 19, okay, divided by A. We want, if you want to get A, you go through this, This is going to become 1.6 into 1.6 into 9 into 10 power. See, 19 into 1938. 38 means minus 31. Whole divided by mass of an, okay, mass of this particular okay, electron. We need to find out acceleration on electron. Remember that. So that's why uh, we need to get A here. A is nothing but, see, D, we forgot to write D. D is how much? This is 1.6 angstrom minute. 1.6 into 1.6 into 10 power minus 20. So this becomes, okay, when it goes to become 20 plus 20, it becomes. So this 39 cancels out around the 10 power. Okay, you will get it as around 10 power 22 meter per second square. Okay, this is what you are going to get. So meaning is you just find out net force acting on charge. Okay, that means electrostatic force is mutual. Whatever the force, okay, on electron, okay, is taking place, same force will also be on the proton. So this is mutual. So mutual force is equal to mass into acceleration. So then you find out acceleration acting on the electron. Okay, right. Then after this, okay, go for another question. 2 point charges minus q and plus q are placed at a distance of L as shown in the figure. Magnitude of electric field at a distance R. So we know that on the, okay, E for axial line is 1 by 4 pi epsilon naught, okay, 2p by r cube. E along equatorial line is going to be done by 1 by 4 pi epsilon naught, okay, 2p by r cube. Okay, like this. So that means that is nothing but whether it is on axial line or equatorial line, okay, the dependence of distance and electric field will be same. That's inversely proportional to r cube. Next one is, if a charge if a charge on the body is 1 nanocoulomb, then how many electrons are present on the body? How many electrons are present? So we know that. So if this is the number of, if this is the charge, how many number of electrons are present? X of electrons to have negative charge. So we know that Q equals to N into E. Q is how much? Q is nothing but 1 nanocoulomb. 10 power minus 9 is equal to 10 power 9 into 1.6 into 10 power 9. Okay, 10 power minus 19. Correct? So this is charge equals to N into E. Charge will be equals to, this is quantization of charge. Quantization means what? Charge of any body can be represented as integral multiple of fundamental charge. Here charge 1 nanocoulomb, 10 power minus 9 equals to N into 1.6 into 10 power minus 19. Okay. So N becomes equal to 10 power minus 9 divided by, okay, 1.6 into 10 power minus 19. So this is going to become 0.625 into 10 power. Okay, when it goes to the numerator, it becomes 10. Okay, then, okay, this is going to become 6.25 into 10 power 9. Okay, 10 power 9 coulomb. Hence, option B. Okay, right. Now, ಇಲ್ಲಿ quantization of charge, we have to apply quantization of charge, that is Q equals to N into E. You just find out how many number of electrons are to be removed in order to have this much a number of positive charge or negative charge depending upon nature of charge that is removed. Next one, when two equal and opposite masses M1 and M2 are accelerated in uniform electric field through same potential, same distance, what is the ratio of their accelerations? If their ratio of masses is M1 is to M2 equals to 0.5. See here, two equal and opposite charges of masses M1 and M2. masses are M1 and M2, accelerated through same electric field, so same distance. S is equals to H. Ratio of their accelerations. If M2 minus M1. Okay. So this is first mass and this is the second mass. Okay. This is what the problem definition is. M1 by M2 is 0.5. We know that okay, both are accelerated through same electric field. Okay, electric field. So we know that F equals to M into A, that's equals to Q into E. You know, Q into E. Now, acceleration is going to be given by QE by M. QE by M will be the acceleration. Okay, so that means acceleration. Okay, at the same distance, I'm calculating the acceleration. That's nothing but Q into E by M. Q is charge, E is the electric field, and M is the mass of the particle. So here, ratio of their masses, two masses is A1 by A2 equals to QE by M into, okay, here it is given, see, here QE by M into Q dash E dash by M dash for second particle. Okay, this is for this you will get U into E is same, and then electric field is same, charge is same. So M dash by M is M dash by M, a point 2 you will get. Okay, M dash by A1 by A2 will be equals to 2. So this is what the answer is. Okay, acceleration of the particles is given by this. Okay, A1 by A2, M1 by M2 is nothing but 2. Okay, 2 is the correct answer. Then go for next problem. Whether Gaussian surface is a vector or a scalar. Okay, remember that always scalar is a surface is a vector. Sorry, surface is a scalar, whereas surface is a scalar, whereas a magnificent or in this particular Gauss theorem, whatever the area we have to use in Gauss theorem, it's a vector. Because if we are finding any electric field somewhere here, we will draw a normal drawn to the surface. Now, if normal is drawn, okay, A dot B, A cross B, nothing but AB sin theta into n cap. Right? Okay, if you are taking the in case of Gauss theorem, while applying Gauss theorem, we will take normal drawn to the surface so that that surface is taken as a vector. Okay, no doubt, surface is a scalar, whereas in certain regions like Gauss theorem, surface is taken as a vector quantity. That's why here it's a Gaussian surface is a vector, not a scalar. Ah. Next here, a spherical conductor of radius 2 centimeter is uniformly charged with 3 nanocoulomb. What is the electric field at a distance 3 centimeter from center of the sphere? Okay, spherical conductor of radius is given as 2 centimeter. We need to find charge is also given as 3 nanocoulomb. We need to find okay, electric field at a distance of 3 centimeter. We need to find. Okay. If this is the case, this sphere of radius 2 centimeter, charge q is given. We need to find out okay this electric field at about 3 centimeter, means outside. E outside is going to be given by 1 by 4 pi epsilon naught q by r square. That's nothing but 9 into 10 power 9. Q is 3 into 10 power minus 9. by r square, distance square. Distance is 3 into 10 power minus 2 whole square. So 10 power 9, 10 power 9 cancels out. Okay, then this is going to become 9 into 3 divided by 9 into 10 power minus 4. This becomes 3 into 10 power 4, 3 into 10 power 4 volt per meter. That's it. So for next problem, the angle between dipole moment and electric field at any point on equatorial plane is 180. Why? Because you think over this. Okay, you see here, this is what electric dipole. No, this is the equatorial line of a dipole. So net electric field will be in this direction. Whereas dipole moment, the electric dipole moment will be in this direction. Electric dipole moment. Okay, the electric dipole moment. Okay, the P is the electric dipole moment and E is electric field. P is electric dipole moment. Electric dipole moment. Okay, so this is E, this is P. Now we go for next problem. Okay, pick out the statement which is incorrect. Electric field lines forms a closed loop. That's wrong. Magnetic field forms a closed loops. Okay, magnetic lines, field lines forms closed loops. Okay, electric field lines never intersect. Tangent drawn to the line of force represent direction of motion of a electric field. A negative test charge experiences a force opposite to the direction of the field. That's correct one. Next one, try you just have a trial here. It's given that two charges. What are two charges given here? 6 microcoulomb, minus 9 plus 9 microcoulomb are separated by distance d. Between them, force of attraction between them is okay proportional to k 6 9 by d square. So F is proportional to okay 6 micro into 9 micro by distance square. Let's say equation 1. If 3 microcoulomb is added, then what happens to the new charges? New charges becomes 3 micro. Okay, 3 micro. Here it becomes 3 microcoulomb. 6 minus 3 or 3 it is given. Minus 3 is given. Here 3. Here also 6 it becomes. 6 and 3 it becomes. Okay, this is d distance of separation. New force is going to be given by 3 micro into 6 micro divided by d square. So F new force is given by F proportional to. Okay. So here are just divide new force with the old force. This is old force. Okay. F new by F old is equal to 3 mu into 6 mu by d square into d square by 6 mu into 12 mu. Correct? Okay, sorry, 9 mu. Mu 6 6 cancels out, d square cancels out. Okay, 3 3 is 1 by 3 times 1 by 3 times. So that means, okay, new force is equal to old force divided by 3 times. Okay, 3 times it decreases. See, here it is given. So first what we did is two charges which are kept separated by some distance. Between them, we calculated the force, and then 3 coulomb is added, and minus 3 is added, 6 becomes 3, 9 becomes 6. New force is calculated. Divide one by the other, you will end up with F by 3. That means one third. Okay, force decreases by one third or 3 times. Here you see, if there is only one type of charge in the universe, let us assume that. Okay, what will happen to the, okay, Gauss theorem in electrostatics? See, there will be no, okay, flux over the surface is zero wherever the charge is. Flux over the surface could not be defined. Flux over the surface is infinity. Flux over the surface is zero if charge is outside, and is equal to q by epsilon naught if the charge is inside. That means, okay, here see, integral over a closed surface E dot ds will be equals to 1 by epsilon times net charge enclosed by the surface. Okay, charge is charges can be isolated, means we can separate. If the surface encloses charge, it will have flux. If surface won't enclose any charge, it does not have any flux. That's why, okay, D is the correct option. Okay, D is the correct one. Next one. This problem and first problem were one and the same. An electron of mass m charge E falls through a height of h in uniform electric field. Time of fall. Already we determined that expression for time of fall. Okay, as see, force acts on the charge is given by mass into acceleration, that's given by E into E. Acceleration equals to E into E by m. Then S equals to 0 plus half of A into T square, or half of A means E into E by small into capital E by M into T square. Our time is going to be given by root of 2mh by, okay, 2meh by small e into capital E. Okay, 2mh. Correct? So T is nothing but 2mh divided by small e into capital E. Okay, so that means, okay, as mass is more, time will also be more. Okay, if mass is less, okay, time taken to cool will also be less. So that's why this will be the correct choice. 2hm by small e into capital E. This is also repeated. We know that electric field on the axial line is equal to twice electric field on the equatorial line with a negative sign. Axial equals to twice the equatorial. Ah, this is once again a, okay, similar problem. Okay, if you have two charges, 2 micro and 8 micro, minus 8 micro, they are separated by a distance of d between them. Okay, d between them. See here, the force between them is going to be given by F naught, let's say, K into 2 microcoulomb into 8 microcoulomb by d square. If they touch each other, go through it carefully. If they touch each other, charges gets neutralized. Plus 2 micro nanocoulomb minus 2 nanocoulomb neutralizers. When they are separated, remaining charges 6 nanocoulomb, remaining 6 nanocoulomb come, okay, 6 nanocoulomb remaining. Okay, here 2 and 2 cancels out. minus 6 remains. Minus 3 will be divided and kept at the same point, same distance. Now new force is given by K Q1 minus 3 nano divided by d square. Okay, so we need to write down f in terms of f. Okay, f we need to write, right? Otherwise, okay, no. Here the new thing is what is the new distance between them to get repulsive force same as that of magnitude as before. Meaning is here f must be equal to f naught. So we need to change the distance. Let's say this is d1 square. Okay, instead of d square. Okay, now force will be same. If it is same, then this will be equals to k into 2 micro into 8 micro by d square. So this will be k gets cancels out, d1 dash square equals to 3 micro 3 micro, okay, divided by this is what 2 micro into 8 micro. This will be 3 into 3 with negative sign only. This is going to become, now we simplify the things which will go. This becomes 9 by 16 into d square. Then d1 equals to 3 by 4d. Okay, see, that's what 3 by 4d will be there. Only thing is, whatever it is given, whatever it is given, you just substitute that, assign the equations, the corresponding equations, divide one by the another, you end up with the result. D1 equals to 3 by 4 D. Next question. You see, if 4 into 10 power 10 electrons are removed from a neutral metal sphere of diameter 20 centimeter placed in air, magnitude of electric field at a distance 20 centimeter from its center. See here, what is given is 4 into 10 power 10 electrons are removed from a neutral metal sphere of diameter. Let's say you will have a sphere, its diameter is 20 centimeter. So charge over the surface is G, Q equals to N into E. N is 10 power 10 into 1.6 into 10 power minus 19. So this is going to become 10 power minus 19. Okay, na? 10 power minus 19 will be the 19 coulomb will be the charge. Now, the metal sphere will have 20 centimeter or diameter placed 20 centimeter diameter. Radius is 10 centimeter. Magnitude of electric field at a distance of 20 centimeter from the center. From here to here. Okay, electric field which is running, you need to know. So electric field is going to be given by 1 by 4 pi epsilon naught Q by R square. Okay, this is 9 into 10 power 9. Okay, then Q is 10 power minus 19 divided by R. R is 3 into distance of separation, that is 20 centimeter, 400 into 10 power minus 2. Okay, 20 means sorry, minus 4. Here Q is, this is given when it goes to numerator 11, let's say 4 by 11 is 2.25 into 10 power minus 8. Okay, electric field, magnitude of electric field at a distance 20 centimeter from the center. How much charge is removed? Charge is 10 power minus 10 electrons. If it is removed, 10 power minus 9, okay, into 1.6, you just removed, okay, into 1.6, into 1.6. Electric field, see, okay, 4 into 10 power 10 electrons are removed from the metal surface. Okay, 1 second, I will rewrite this. Okay, 1 second, we will rewrite this so that you will let you know better. So what happened here is I missed 4. So let's see how actually this is going to be done. It's a very simple problem. Okay, but the only thing is you have to be very careful while taking the readings. Okay, readings itself will be the hectic in taking here. So what is happening here? Here, so many number of electrons, 4 into 10 power 10 electrons, okay, are removed from the neutral surface of a sphere of radius 20 centimeter. Sphere of radius 20 centimeter. Okay. The magnitude of electric field at a distance of 20 centimeter from the center. Okay. Magnitude of electric field at any distance from the center is given by 1 by 4 pi epsilon q by r square. This is 9 into 10 power 9 into what is the charge corresponds to this? Q equals to n into E divided by r square. 9 into 10 power 9, n is 4 into 10 power 10 into 1.6 into 10 power minus 27. Okay. It's sorry, charge with minus 19. 1.6 into 10 power minus 19 divided by distance square. Distance is 400 into 10 power minus 4. Okay. So you now simplify this. 400 remains here. So then you can see 9 into 1.6, 54, 4 carry, 1 remain, 40, okay, 9 6 are 54, 5 carry, 9 1s are 9, okay, 9 144, okay, 144, okay, 1 decimal point, okay, 14.4 into 10 power, see here, 10 19 cancels out, overall this becomes 2440 volt. That's it. Okay, this is how you need to simplify the problem. Next problem is just go through it. Here this is very easy problem. There are 2q and 4q are placed at corners ABC of an equilateral triangle of side V. Okay, of side not V. This is X actually. Of side X. Magnitude of the electric dipole moment of the system. See, we are placing dipoles at different points. Okay. X, X, X. So this is X value. Let me keep 2q here, 2q here, minus 4q. Okay, minus 4q. So our idea is to find, okay, what will be the net dipole moment of the system. Okay, go through this. In order to become a dipole, to be a dipole, two identical okay, due to be diode. Okay, see, one second. In order to have these, this system to behave as what we call a dipole. For a dipole, two equal and opposite charges, are to be separated. See, like this. Now, this diagram, just I will modify this diagram, go through this. Is it possible? You check it. 2q minus 2q. 2q minus 2q. See, this is how the things are going on. Now if you just find out dipole moment. This is P1. This is equals to 2L into Q. okay, 2L into, okay, Q, okay, or this is 2, or this will be 2L into X actually, not L, 2LX. Instead of this is also, okay, this will be where 2L into, okay, this one. So you go through it, 2, or 2L into 2L, P2, 2L, Q2, or 2LX, ಇದು ಕೂಡ P2. P1 equals to P2 and makes an angle 60. Hence, P resultant is equal to P1 square plus P2 square plus P1 P2 is on, okay, to plus P1 square plus P2 square plus 2P1 P2 into cos theta. Okay, just get that P1 square plus P2 square plus 2P1 P2 cos theta. So this is going to become P1 square. P1 square is nothing but P square plus 2P square into, okay, this is what, into 2P square into cos theta, because P1 and P2 are one and the same here. And this theta is 60, cos 60, okay, we'll have only a half and this cancels out. Then P resultant is equal to root 3 times P1, P2, P3. Sorry, P1, okay, root 3 times P. This is root 3 times P. What is P? P is nothing but 2LX, root 3 into 2L into Q. Hence, okay, 2L into Q or 2XQ. L or X. P resultant will be equal to root 3, 2 root 3 into QX. Okay. L or X, that is your choice. 2 root 3 QX, first option. Okay. Next problem is, this is also a very simple problem. Magnitude of point charge due to which electric field 30 centimeter away has a magnitude. Electric field is given as 2 Newton per Coulomb. Distance given as 30 centimeter. Okay, magnitude of electric field, that's V is to be determined. Okay, which has a field, okay, and has a magnitude of 2 Newton per Coulomb. Okay, electric field also, okay, this D is 30 centimeter. From the electric charge 30 centimeter at a distance, you need to know what will be the charge. Okay, magnitude of charge, okay, magnitude of point charge due to which point charge is there, due to which at a distance of 30 centimeter, what is electric field produced is 2 Newton per Coulomb. We know that electric field is equal to 1 by 4 pi epsilon naught q by r square, r q by x square. This is 9 into 10 power 9 into q. Q, that is what we need to find out. This is 2. Okay, this is divided by r is how much? Distance. This will be 900 into 10 power 4. Okay, then this will become equals to q equals to 18 into 10 power minus 4 divided by 9 into 10 power 5, 9 into 10 power 5. Okay, 9 to the 0, 0. Okay, so then it's going to become 2 into, this will be 2 into 10 power, it goes to numerator, minus 9, okay, minus 9, 5 minus 9. This will be 18 into 10 power 4 by 10 power 9. This okay, this is 9, not 5. This will be 9, so that everything will be clear. This will be 9. Now go through it. 9 to the, so When 9 goes to numerator, this becomes minus 13. 13 minus 2, 11. 10 power minus 11 coulomb. 2 into 10 power minus 11 coulomb. Okay, so this is how we can able to do the problems. Okay, this is see here. This is once again we are getting back to Coulombs law. Very important problem it is. Very important from the point of view of examination is considered. See, it is appeared in 2018. Force of repulsion between two identical positive charges. Let us say Q, Q. Kept separation by R is F. F equals to some 1 by 4 pi epsilon naught Q square by R square, equation 1. If half of the gap between two charges is filled with dielectric medium, out of this, half the gap is to be filled. This is R by 2, K, Q, Q. Okay. Dielectric constant K equals to 4. Then new force of repulsion between them. New force F dash equals to 1 by 4 pi epsilon naught. Okay. Q into Q, Q square. Okay. R is nothing but okay, this will be R minus T plus T root K whole square. This is what general equation we are using. Okay, so okay, so that's why this becomes 1 by 4 pi epsilon naught Q square divided by R. Minus of T means okay, R by 2 plus T means R by 2. Root of K means 2 whole square. This will cancel out. This becomes R by 2. R plus R by 2 is 3 by 2 R. Okay, if this is simplified, F dash will be equals to 1 by 4 pi epsilon naught Q square by, okay, 3 by 2 means 9 by 4 R square. This becomes 4 by 9 into 1 by 4 pi epsilon naught Q square by R square. So this becomes 4 by 9 into F you are going to get. Okay, this will be 4 by 9 into F. Okay, that means option D is the correct one. See, this type of problems are very important from the point of view of examination because this is a new type. We cannot completely fill it with dielectric medium. If half is filled, 3/4 is filled, 1/4 is filled, how actually you can able to get force between the two charges, right? This is what one type of problem, and next one is go through it. Okay, this is also one peculiar type of problem. Okay, different type, cannot a similar one. Okay, a certain charge 2q is divided into first into q1 and q2. Okay, later charges are placed at certain distance. If force between two charges is maximum, what is this? 2q is divided into q1 and q2. Okay, if q, then q2 becomes equals to 2q minus q1 because it is divided. It's divided, hence q2q, out of that q1 and q2. Q2 means 2q minus q1. Okay, out of q2, 2q, if q1 is removed, what remains? 2q minus q1. Okay, these are the two charges. Placed at certain distance, force of interaction between them is given by k into q1, q2 by d square or r square. Now substitute that F equals to some k into q1 is what? q1 as it is, q2 means 2q minus q1 whole divided by r square. So if F is to be maximum, what is the maximum value of F? Whenever a function attains maximum value, its a differential with respect to variable in the problem becomes equal to 0. That is what here. Here variables are Q1. Hence, df by Q1, dq1 is equal to K Q1, okay, by R square 2K. Okay, see, this is what, okay, equation just remove the things which are constants here. Differentiate. K by R square is constant. Q1 keep it as it is. Okay, or like 2Q is constant. No, you can differentiate. Like just go through it. I will do. Just go through it. F is given by this. When F is maximum, df by dq1 will be equal to 0. That's equals to K by R square into d by dq1 into 2q q1 minus q1. This implies 2q minus 2q1 will be equal to 0. This implies q1, okay, q by q1 equals to 1. Q by q1 minus 1. You are going to get. So, sorry, plus 1 only. Q by, this will come this side now? Yes. Okay, 1. You are going to get Q by Q1 equals to 1. That means Q1 equals to Q. Q2 is also equals to Q. That means if they are equally divided, force of attraction or repulsion between them becomes maximum. Remember that. If they are equally divided, force between the charges will be maximum compared to any other possibilities. An electric dipole is kept in a non-uniform electric field. It experiences both force as well as torque. Force and torque. Why? Because if there is a uniform electric field like this, okay, if you have a charges Q1 and Q2, okay, uh, this is what if it is kept now, okay, this force and this force only acts, which will cancel with each other. Rotating effect produced by a force is called the torque. A rotating effect is like this. If we keep an object here, okay, here force will be different, here force will be different. Hence, in this case, torque as well as, okay, force acts. Okay, on this. This is what happens in case of a dipole placed in an electric field. Ready? Whenever it is kept in a uniform electric field, no doubt torque acts. If it is kept in non-uniform electric field, torque as well as force acts, both. Okay, rotating as well as translatory motion takes place in a non-uniform electric field. An infinitely thin long wire has a charge density. See, lambda is given.
Excuse me, sir.
Sir,
Sir, actually, it's break time now. We'll continue at 6:05 again from this question.
yes, sir. Okay, sir. Okay, thank you, sir.
Yes, sir. The
Yeah, thank
students, you have break till 6:05. Please join back again, or else you can be in the session itself. So join back at 6:05. And any other doubts, anything you can ask, sir, or you can just send in the QA box. And the PDFs for all the discussed topics will be shared in the group by end of the session. So don't keep on spamming the QA box for asking about the PDFs which are to be shared. So don't worry about the PDFs; it will be shared. So please have your break. We'll continue at 6:05 again.
Welcome to the School of Engineering at Dayanand Sagar University, main campus, Harohaldi, Kanakpura Road, Bangalore. A place that values research, innovation, and creativity. Our industry-aligned curriculum offers a blend of theoretical knowledge, practical experience, academic projects, and internships for a rewarding career in engineering. With an interdisciplinary approach, you can explore your interests by selecting open electives. The on-campus innovation labs, led by professors of practice, provide immersive learning and expertise to find the best solutions to real industry problems and give a different dimension to the students' mini and major academic projects. Our Center for Entrepreneurship supports startup opportunities and provides a perfect platform to launch your next big idea into successful ventures. We also prepare you for advanced studies in the latest futuristic technologies. Our BTech programs offer the perfect combination of academic rigor and functional experience in this ever-evolving technological landscape of the future. Experience a whole new world of academic excellence in a global environment. Dayanand Sagar University. Live the dream.
Okay, so students, if you have any doubts, you can ask me. Any questions? Any queries relating to CET program, related to the session? Yes, the session will be going on. We'll start at 6:05 again. So please be in the session. Manjunath sir, we'll start the session again. Sir, are you there? Hello, Manjunath sir. Sir, are you there? Sir, we'll start the session, sir. Sir, your voice is not audible, sir.
Okay.
Now it's audible, sir.
Okay. Fine. Thank you.
Yes.
Okay. I'll present this. Okay. Can you be able to see the screen?
No, sir. Now it's not visible.
Okay. 1 second. I will okay, select it. What about now?
Sir, it's visible now, sir.
Yeah, thank you. Thank you very much. Okay. So we'll continue with this. Go through it. An infinitely long thin straight wire has a uniform charge density of 1 by 4 into 10 power, okay, 10 power minus 2 coulomb per meter. Remember that by going through the unit, I can decide that this is linear charge density. This is linear charge density. Okay, what is the magnitude of electric field at a distance 20 centimeter from the axis of the wire? Means at a distance of 20 centimeter, I need to find out what is known as electric field. Okay, right. So here you go through it. This is from linear charge density. We know that electric field is given by 1 by 4 pi epsilon naught 2 lambda by r. So this is nothing but 9 into 10 power 9 into 2 into 1 by 4 into 10 power minus 2 divided by r is nothing but RRD, whatever it may be. This is nothing but 20 into 10 power minus 2. So if it is simplified, see, so how it is to be simplified? This 10 power minus 2, 10 power minus 2 cancels out. Then it becomes 2 tens, okay. Then 9 by 4, this becomes 2.25. Okay, 9 by 4, this is completed into 10 power 8 remains. Okay, here 10 power 9 by 10 Newton per coulomb. This will be the electric field at a distance of d, that is 20 centimeter from the given line of charges. So we'll move on to the next question. So once again, the same question repeated. Okay, now, okay, now see here. An electric field lines on the left have twice separation on those on the right as shown in figure. If the magnitude of field at A is 40 volt per meter and charge of 20 microcoulomb is kept at B, what is the force on it? If I keep a charge of 20 microcoulomb here, what will be the force? See here, we know that electric field means E means number of lines per area normal to the surface. Okay, here the lines are closer means here electric field is more. Here lines are wider means electric field is less. Okay, lines are wider means electric field is less. By how much less? Half, because it is double the distance. That means electric field at B is K equals to electric field at A by 2. Because lane separation is more, electric field is less. Hence, electric field at this point is 40 by 2. It is 20 volt per meter. And charge at B is how much? 20 microcoulomb. So force on charge is going to be given by Q into E. So Q is 20 into 10 power minus 6 into K20. So this becomes 400 into 10 power minus 6 or 4 into 10 power minus 4 volt per meter. Sorry, a volt per meter, or this will be a force, okay. This, what is the force? Okay, force now volt per in volt per meter only represented 4 into 10 power minus 4. Okay, so that's why first option is the correct one. Okay, like this. So this is force acting on a charge is going to be given by Q into E. Based on that, we can able to simplify this problem. See here, electric field due to infinite straight uniformly charged wire varies with distance as. So we know that for a point charge, electric field is given by what? KQ by R square. For a sphere, E is given by k cubes by r square once again. For line of charge, infinite line of charge, E equals to 1 by 4 pi epsilon naught 2 lambda by r. That means E is inversely proportional to r. That's why this will be the correct option. Okay, how it depends. For a direct dipole, E is inversely proportional to r cube. Okay, like that. So I think these are the problems and these are the questions we have solved from first chapter of electrostatics. Okay. Now we will move on to electrostatic potential and capacitance. Right? By assuming that or by thinking that you know basic ideas on it. If okay, for everything I will write down the things which are required to solve this particular problem. Let's go directly into the problems. The electrostatic force between the metal plates of an isolated parallel plate capacitor C having a charge of Q and area A is independent of distance between the plates, linearly proportional to distance between the plates, inversely proportional to distance between the plates, proportional to square root of distance between the plates. See, what they are asking is electrostatic force between the metal plates. Let's say we will have charges here, plus here on one plate. Here we will have negative charges on the another plate. Find the electric field here. Let's say at P, E at P is going to be given by sigma by epsilon naught. Okay, sigma by epsilon naught means Q by epsilon naught into A, because sigma is nothing but Q by A. Q is charge on each plate. Okay, so this plate, this is negative charged plate, is attracted by positive charged plate. Positive charged plate is attracted towards negative charged plate. Hence, force is going to be given by Q into E. So that's why this is Q into Q by epsilon naught A. That's going to be given by Q square by epsilon naught A. That means it is independent of distance between the plates. Okay, linearly proportional to distance between the plates, inversely proportional to distance between the plates, and proportional to, that means it is independent of distance between the plates, means it won't depend on distance between the plates. Hence the first option is correct. See, force between the charges is given by Q square by 2 epsilon naught A actually. Okay, this will be 2 epsilon naught A. So electric field at that point due to one plate only, Q by 2 epsilon naught A. Okay. So Q square by 2 epsilon naught A is the force acting on each plate by the other plate. Okay, is the force on each plate by another plate. One plate attracts the another plate by a force. That force is given by this. Okay, Q square by 2 epsilon naught A. So it is independent of this distance D. So go for next problem. See here, the diagram is given here are equipotential surfaces. What is equipotential surface? Potential over that particular surface remains constant. That surface is called equipotential surface. Okay, so here we need to check in which case work done is maximum to move the charges. See, okay, and once again, these forces, work done, remember that independent of path, because these are conservative force fields. Electrostatic force is conservative force, hence work done is independent of path. Independent of path followed. Here you see, from A to B, this is 10 volt, this is 30 volt. Okay, na? From here to here, work done is, okay, work done will be 40 minus 20. Here, work done in first case equals to Q into delta V. That's equals to Q into a positive charge Q into 40 minus 10. This is 30 Q. Q in case of B, okay, 10, 40. So same, Q into 40 minus 10, that is 30 Q. Work done in C, this is 10, 40. This is Q equals to 40 minus 10, that's 30 Q only. So W in D is given by, okay, to for 10 minus Q into 40 minus 10, that's equals to 30 Q only. So in all four cases, work done is same because their work done won't depend on the path. It depends on the initial position and final position, initial moment, initial potential and the final potential. Hence, in all these cases, work done will be same. See, potential difference is 30 here. Here also 30. Here also 30. Here also 30. Correct? Ah? So that's why work done will be same. Next one. Here you see. A charged capacitor is charged by a battery. Battery is removed and another identical capacitor is connected in parallel. Total electrostatic energy of the system. Electrostatic energy of the system. See here. Once capacitor is charged, when C is charged, electrostatic energy is given by half of CV square. Call this the equation number 1. A battery is removed and another identical, okay, C comma V, C comma 0 volt. If it is connected, you will get common potential difference. How much is the common potential difference? You will get C1 V1 plus C2 V2 by C1 plus C2. This is the common potential appeared whenever one capacitor is connected in parallel with the another. So CV plus 0 plus by C plus C. So that means V by 2. Okay. This potential reduces to half. Then Cp equals to C1 plus C2. That means C plus C equals to 2C. Capacitance also gets doubled. So total electrostatic energy of the system becomes, final energy will be equals to half of Cp into common potential square. This case half of Cp means 2C into V by 2 whole square. This is going to become, what is going to become is half of 2C into V square by 4. This becomes half of C V square into half. That means initial by 2 it becomes. Okay, it decreases by a factor of 2. See, this is UI is half CV square. UF is half of half CV square. Hence, decreases by 2 times. Okay, this is what, because when battery is connected, this much energy will be stored. Okay, when it is removed, its your capacitance C, potential is V. When uncharged capacitor is connected, charges will flow until both will attain the same potential. When once they attain the same potential, final energy is given by half of half CV square, that is reduced to half. Next one, go through this. This is also similar type. Capacitor of 2 microfarad is charged as shown in figure. This is charged by connecting the switch to 1. See here why it is connected to 1. It is charged. When it is charged, initial energy is given by half of C into V square pi. C, half of C means 2 microfarad. V square will be equals to, okay, anyway, half of C into V square, this is better compared to these numbers. When the switch is turned to the position 2, percentage of energy dissipated is, when switch is turned to this point, turn to second. Okay, initially 8 microfarad is uncharged. When switch 2 is connected, okay, common potential is achieved. V common equals to C1 V1 plus C2 V2 by C1 plus C2. C1 V1. C1 is C1 2 microfarad into V plus C2 8 micro into 0 by 2 microfarad plus 8 microfarad. V common potential will be equals to, okay, 2V 2V by 10. That means 0.2 V. You are going to get 2 microfarad into 8 microfarad by 10 microfarad. So micros cancels out. 2 micro, 10 micro. Get 8 plus 10 remains. Okay, 0.2 V. And Cp will be equals to C1 plus C2. That's nothing but 2 plus 8 equals to 10 microfarad. Then final energy is given by half of Cp into common potential square. Half of Cp is 10 micro into common potential 2V by 10. 2 are 0.04 into V square. Okay, this is the energy. Okay, final energy. Okay, then UF minus UI by UI into 100% is the energy. Okay, percentage of energy stored dissipated. Energy dissipated. Percentage of energy dissipated is given by this. Okay, so this becomes equals to how much it will be? This becomes 0.04. Otherwise, this will be final energy or initial energy minus final energy. Initial energy is how much? Mu into V square. Mu V square minus, okay, here 5. 5 4 is 20. 0.2 mu V square divided by initial mu V square. Mu V square, remove it. Okay, 1 minus 0.2 is 0.8. Okay, 0.8 or 80%. 80% of the energy will be lost during this process. Meaning is first capacitor is charged and it is connected to the second capacitor. Then during this, energy dissipation of 80% takes place. How it is determined? First you find out the energy stored in the first capacitor. After that, when it is disconnected and connected to the uncharged capacitor, find the common potential, then find the energy of that system, second system. Take the difference. Divided, if I take the difference, loss of energy you are going to get. If it is divided by initial energy, you will get fractional change. If it is multiplied by 100, you will get what is known as percentage change. Okay, I will write on that. UI minus UF gives you loss of energy. UI minus UF by UI gives you fractional loss of energy, fractional change or loss of energy. Okay, UI minus UF by UI into 100% gives you percentage loss of energy. Okay, that's all. So this is how the problem is going to be solved. Next, move on to the next one. See here, a parallel plate air capacitor has a capacity of C. Distance of separation between the plates is D, and potential difference is V is applied between the plates. Force of attraction between the plates of a parallel plate air capacitor is. Force of attraction between the plates of the air capacitor is. We need to find out. Here we have a capacitor plates. This is how we'll have the plates. D is distance of separation. Okay, V is the potential of this. This potential is 0. Okay. Force between the plates. Force between the plates is going to be given by Q square by 2 epsilon naught into A. Okay. So Q is nothing but Q equals to C into V. Then it becomes C square V square by 2 epsilon naught into A. So C equals to epsilon naught A by D. So C square V square by 2 epsilon naught A means C into D. 1C cancels out. So CV square by 2D. CV square by 2D. Just manipulations, that's all. Just by substitutions. Okay, whatever the terms which is required, you retain it. The terms which is not required, you just cancel it. You'll end up with the result. Okay, right. This is what the problem. If a potential is given at a particular point and you are asked to find out electric field. So we know that what is the relation between electric field and potential? E equals to minus dV by dx. If it is one dimensional, if it is three dimensional, it's given by del dot V. Divergence of V is nothing but electric field, or E will be equal to minus I into dou V by dou x minus J into dou V by dou y minus K into dou V by dou z. So take up this V. V equals to 6xy minus y plus 2yz. Okay, differentiate this with partially with respect to x. What is partial differentiation? When we are differentiating with respect to x, y and z are constant. If we are differentiating with respect to y, x and z are constant. If we are differentiating with respect to z, x and y are constant. Now we are differentiating with respect to x, hence y and z are constant. Y is constant here. So 6y minus 0, constant differential of constant is 0. This is 0. Okay, plus 0. That's it. Similarly, dou y by dou y, dou v by dou y, 6x minus 1 plus 2z. Then dou v by dou z, 0, 0, 2y. Then E becomes equal to minus 6yi minus j into 6x minus 1 plus 2z plus, sorry, minus minus 2y into k. So we need to find I at what point? 1, 1, 0. At 1, comma 1, comma 0, E will be equal to minus 6i minus j into 6, okay, minus 1, that's it, 0 it is, minus 2k. So minus 6i minus 5j minus 2k. If I remove the minus sign, 6i plus 5j plus 2k. 6i plus 5j plus 2k with negative sign. So this is the relation between electric potential and electric field. So electric field is equal to negative gradient of potential. D by dx is called gradient. Okay, gradient is obtained in this particular way. For CET level, some very simple question, very simple potential will be given. Okay, this is little bit higher level question. That's why all the parameters are given. Okay, right. We'll move on to the next question. So exactly similar type of question. You can try this. Say potential is given. You are asked to find out electric force. Force is nothing but charge into electric field. First you find out the charge. find the electric field at this point, and then multiply with the 2, you will get the force. Okay, first you find out the field. Okay, E equals to minus dV by dx. V equals to 6x minus 8xy minus 8y plus 6yz. Okay, so dou v by dou x is equal to minus of, okay, x now, this is 6 minus 8y, that's it. Dou v by dou y equals to, okay, y only, no, minus of 8x, okay, minus 8, that's it. Dou v by dou z, okay, we don't have z term in the first, second, third, fourth, 6y. Okay, hence E equals to minus I into dou v by dou x. 6 minus 8y minus j into minus 8x minus 8 plus k into 6y. At 1 comma 1 comma 1, electric field is going to be given by 1 if I substitute, you
Sir, your video and audio got stuck, sir. We can't hear you. We can't see you properly. The video is stuck. Yes, Tanish, what is your doubt? You can place it in the QA box. Students, please wait. There is some network issue, so that's why the video is stuck, and we are about to begin again. I just now called sir, and sir is again joining back, so it will be proper. Don't worry. Just be in the session. Except that, any problems you guys are facing in the session, or anything you are not able to understand and it's going too fast or something, you guys can tell me here. You guys are bored? How many of them are bored? Raise your hands. I knew, Tanish, I knew you will raise your hand. It's okay, it's okay. Boring, no, still you have to study. You have to clear your CET exams, no? So you need to study. I'm also studying with you guys now. I'm pass out, still I'm studying physics. I used to hate physics before, but I have to study. Kirtana, I didn't get you because unit test first questions and solution. 15th. Kirtana 15th, sir, will be discussing the questions he sent. Right, Sneha, we used to divide it, and before we had this program itself like that, like 2 hours different subject, 2 hours different subject. We'll keep this in mind, and we'll try to do that also. But it's like in one session there are students, and in another session students will leave. So that's why, because of irregularity of students, we are not conducting like that. So we are focusing on one subject to be kept. So that's the reason why we are keeping the whole 4 hours the single subject. So if I get the guarantee that students are not leaving in the second session, I'll keep 2 different subjects in one day. So please ask your friends to stay in the session and study well, because we have registration for so many students, but it's like 40% students are joining in the session. Other than that, no one is there. So if I get around 80% of proper response, then I can think about it and I can keep it like 2 subjects a day. I think sir is here. Sir, we are good to go, sir, again. So we'll start the session. Sir, your voice is not audible. Sir, are you there, sir? Yes, sure, Karthik. I'll send it. Wait. I've sent in the chat box, Karthik. You can join it through there. And please be in the session. I think sir's network issue is not yet resolved. He'll join back soon. Don't leave the session.
Okay, are you okay, sir, now? Yeah. Can you able to hear? Can you hear me?
Yes, sir. Yes, sir.
Yes, sir.
Continue.
Thank you, sir. Thank you. I will present the screen. Once you check, tell me whether screen is presented or not. Can you able to see?
Yes, sir.
Yes, thank you. Okay, thank you very much. See, this is what the problem we are discussing now previously. Yeah. See, go through this. A conducting sphere. Conducting sphere is one where charges are residing only over the surface. When the charges are residing only over the surface, electric field inside the sphere is zero. Because electric lines will not penetrate inside the conductor or will not penetrate inside the sphere. Hence, right side I have written the graph, go through it. Electric field inside the sphere is zero and it is maximum at the surface and outside it decreases like this. Okay. Whereas, see here, potential, when electric field is constant, zero, potential will be constant. Inside it is constant, outside it decreases. How much is inside? Inside 1 by 4 pi epsilon naught q by r. Hence, I can choose this as the option. Electric field inside is constant. Okay, sorry, electric potential inside constant, whereas electric field inside is zero. Okay, next. This is the problem where effect of dielectric is to be studied here. What is dielectric? Dielectric medium is nothing but it's an insulator. When it is kept in between plates of a capacitor, its capacitance increases. Remember that capacitance increases, electric field decreases, potential decreases. Okay, all these things we have studied in theory. What is the effect of dielectric medium? That's what I have written here. See, electric field decreases by k times, potential decreases by k times, capacitance increases by k times. Okay, and now go for it. This is the condition. Two dielectrics are introduced. Let's say I'm going to plot the graph of electric field versus distance. Up to this, we have an air medium. Up to this, it is air medium. Electric field remains the same. Due to this dielectric medium here, what happens? Electric field decreases. It decreases, let's say. In this region, it decreases. Once again, air medium here. So that it will be maintained constant. Once again, here you see dielectric medium, presence of dielectric medium in this region. But that too, K1 is less than K2 means effect of K2 is more. That's why decrease in potential will also be more. Then here air medium, here it will be retained. Check this. That is satisfied by this. Correct? This is the initial electric field. Here it decreases due to the dielectric. Here it decreases more. Why? Because this is the effect of K2. This is due to effect of K1. K2 is greater than K1. That's why decrease in electric field is also greater for K2 compared to K1. Okay, that's why option C. See this question. How electric field vary with this particular dielectric? That's what we need to study here. Okay, right. Next one. This you can easily tell because so many number of times discussed here. Variation of electric potential with radial distance for a center of positive charged metallic thin metallic shell. Okay, if you have a thin metallic shell, how electric potential will be varied? Potential, electrostatic potential, remember that, not electric field. How electric potential varies here? Okay, potential remains constant inside, outside it goes on decreases. Hence, this will be the case. Next one. See this? A parallel plate capacitor of area of cross section A, separation D as an air between the plates. Now an insulating slab of same area but thickness D by 2 is inserted between them, as shown in figure. K equals to 4. Ratio of new capacitance to original capacitance. Let's say C be the new capacitance. C naught be the original capacitance. What is the original capacitance here? Epsilon naught A by D. This is known. Now, when it is introduced, remember that here it is air medium. This is equivalent to two capacitors. Like this. This is filled with dielectric medium K. Its thickness is D by 2. Distance between the plates is D by 2. Area is A. Here area is A. Let's assume that this is C1. C1 is given by what? Epsilon naught A by D by 2, or 2 times epsilon naught A by D. What about this? This is nothing but C2 will be equals to K epsilon naught A by D by 2. That means 2 times K epsilon naught A by 2. Okay. K is how much? K is 4. 4 2s are 8 epsilon naught A by D, or 8 C naught it is. Because epsilon naught A by D is nothing but C naught. This is nothing but 2 C naught. These two are C1 and C2 are in series. And so 1 by C equals to 1 by C1 plus 1 by C2, or C equals to C1 C2 by C1 plus C2. This is going to become C1 is what? 2 C naught 8 C naught by 10 C naught. C becomes equals to 8 to the 16 by 10. Okay, 1.6 C naught. Okay, now ratio we need to find. Okay, this is C by C naught we need to find. C by C naught is nothing but this is 16 by 10 now. So this is 16 by 10 C naught by C naught cancels out. 16 by 10, or this is 8 by 5. Okay, 8 is to 5. See? So this diagram is equivalent to two capacitors connected in series. One capacitor will have air capacitor, other one is the capacitance with dielectric medium in between. Okay, so that particular capacitance you need to find effective capacitance. So effective capacitance, okay, so that is CS is nothing but RC equals to C1 C2 by C1 plus C2. Original capacitance is epsilon naught A by D, that is C naught. Okay, C by C naught is found to be 8 by 5, or 8 is to 5. Next one. Here, capacitance of parallel plate capacitor with air as the medium is 6 microfarad. With the introduction of dielectric medium, capacitance becomes 30 microfarad. The permittivity of the medium is, very nice question. See, here what is happening is capacitance of air medium in between means we will have a air capacitor like this. Its capacitance is 6 microfarad. When I introduce a dielectric medium of dielectric constant K, okay, how much it will be? C becomes equals to 30 microfarad. Okay, then this is going to become K will be equals to C by C naught. Okay, it's the ratio of capacitance of capacitor in the presence of dielectric to capacitance of capacitor in the absence of dielectric medium. That means 30 by 6. That will be 5 Coulomb square per Newton per meter square. That's it. No? That's it. Okay. So like this, you can able to find dielectric constant or permittivity of the medium. Next one, here. Parallel plate capacitor has a uniform electric field E in the space between the plates. If the distance between the plates is D and area of plates is A, energy stored in a capacitor. Okay, I think we won't get such equations, but we knew these equations. Energy stored in a capacitor is Q square by 2C, or half of CV square, or half of Q into V. These equations are very familiar. But in terms of E, we don't get. See, go through this. What factors you have to get is, we don't want the equation in terms of C. We don't want the equation in terms of V. We need equation in terms of E. So let me take up this. This is the easiest one. Half of CV square. C equals to epsilon naught A by D 1, and E equals to V by D. Use these two. Electric field is nothing but potential per unit length. Use these two. Half of C means epsilon naught A by D into V square means V square is V is nothing but E into D. So that's why, okay, this becomes, okay, this is going to become E square D square. 1D cancels out. Half of, okay, epsilon naught A E square D. But this is what we need to find is energy stored between the, for the area A, okay, and the distance between the plates is D. Okay, so this is going to be given by half of epsilon naught E square A into D. That's what. Half of epsilon naught E square A into D. This is energy stored for a volume of AD. Volume of AD. See, for an area A, area of each plate A, and distance between the plates. If you want to get energy density, so energy density, this is given by U by AD. That's equals to half of epsilon naught into E square. If you are asked to find this, okay, you go for it. If you are asked to find only energy, half of epsilon naught E square into A into D. Okay, right. Next one, see here. This is one more interesting one, but it appears to be very simple. But many students will make mistake in calculating effective capacitance between A and B. Okay, our effective capacitance as shown. Let's see, this is A point and this is B point. See it. Here, what is happening here is, so see here, when I charge this by connecting a battery between A and B, charges will flow and settle here. Charges will flow and settle here. From here also they will flow. Okay, what about here? Here, see, potential at this point is same as potential at this point. This capacitor has no effect since it is shorted. So remove it. This is equivalent to saying that, okay, A, B, so two capacitors are in parallel, you will get this. C plus C equals to 2C. That's it. Okay. But we need to identify. See, if it is connected, like assume that if it is connected to positive terminal, connected to negative terminal, okay, they get charged here. Positive, 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 negative, 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 negative. Here potential here and potential here will be same. Potential difference here will be 0. That's what. So no charges will be stored. Next one. So for this, here we will discuss detailed analysis of how to get such, if we are going to get such problems, how we are to simplify the things. Before going into that problem, let's see if n number of smaller drops form a bigger drop, n number of charge q, each charge, and potential V, capacitance C, energy stored is U. Combines to form bigger drop of radius smaller. Okay, bigger drop of capital R charge, radius, capital Q charge, capital V potential, capital C, capacitance, capital U be the N. As charges Q equals to N into Q. This is the relation. Charge just gets added up. That's all. Okay. So when N smaller drops combines to form bigger drop, volume of N drops is equal to volume of one drop. That means N into 4 by 3 pi r cube will be equals to 4 by 3 pi into r cube. 4 by 3 pi cancels out. This implies r cube equals to n into small r cube, or r will be equals to n to the power of 1/3 small r. This formulas you need to remember. Then potential. Potential of bigger drop is equal to 1 by 4 pi epsilon naught. Charge on the bigger drop divided by radius of the bigger drop. That is 1 by 4 pi epsilon naught n into small q by n to the power of 1/3 into small r. That's equals to n to the power of 2/3 into 1 by 4 pi epsilon naught q by small r. This implies potential of the bigger drop is n to the power of 2/3 into smaller drop. Potential of the smaller drop. Then capacitance of bigger drop equals to 4 pi epsilon into r. That's equals to 4 pi epsilon naught n to the power of 1/3 into small r. Or capacitance equals to n to the power of 1/3 into small c. Again, energy stored. Okay, energy stored in a capacitors. Energy stored, okay, what are the things? Okay, this is what enough radius, potential, and capacitance. See how they are related. Now get back to this particular problem now. Now 27 drops of small size are charged at 220 volts. If they combine to form a bigger drop, calculate potential of the bigger drop. Directly use this. We know that. Okay. Potential of the bigger drop is equal to n to the power of 2/3 times smaller drop. This is 27 times 2 by 3 into 220. 220 volts. Each one will have 220 volts. I think. Yeah. Each one will have 220 volts. This I can write down it as, see, 27 can be written as 3 cube to the power of 1/3 whole to the power of 2 into 220. This is going to become cube root and cube cancels out. 3 square into 220. 3 square means 9 into 220. This is going to become 0. 9 2 is 18. 1 carry 18. 1980 volt. Right? Go through it. 1980 volts. If not, okay, you are supposed to go through complete thing and you have to calculate this. Okay, better to remember these formulas. Okay, directly we can use these formulas to get the required quantity. This is also required. Okay, required quantity. If you are asked to find radius of the bigger drop, use this formula, r equals to n to the power of 1/3 small r. If you are asked to find out potential, v equals to n power 2/3 v. If you are asked to find capacitance, c equals to n to the power of 1/3 times c. Okay, directly you can use. Okay, using that we arrive at this particular value. Otherwise, you have to think of all these things every time you are going to find capital R, V, C like that. Okay, better to remember shortcuts like this. Right. Okay. Tell me what is this? What is equipotential surface? Surface where potential remains the same is called equipotential surface. Okay. And electric lines. How the electric lines, angle between electric lines and equipotential surface will be. See, I will take up with a line dipole plus Q minus Q. This is equatorial line. Line of dipole is an equipotential line. Why? Because this potential due to dipole is given by 1 by 4 pi epsilon naught P cos theta by R square. Theta means this. Theta is 90 for an equatorial line, equatorial plane. That's why it is 0. Potential at every point is 0. Okay. Here charges you go through it. Charges will be like this now. How the charges will be perpendicular. Or one more I will give you example. If the electric lines are like this, if I consider a plane like this, potential at this point is same as potential at this point. Hence, this is equipotential. Always, electric lines are perpendicular to equipotential surface or line. Hence, 90. Okay, angle between equipotential line as well as electric lines is 90 because they are perpendicular to one another. Then only they become equipotential. Now, you come back here. This type of problem already we did. Let's do it once again. Capacitor is charged to 900 picofarad and charged fully. Okay, 900 picofarad. This is 900 picofarad and charged fully as shown in figure. This is 900 picofarad. Okay, and charged fully. Then it is disconnected from battery and disconnected to and connected to another uncharged capacitor of capacitance 900. This is also 900 picofarad, 900 picofarad connected as shown in figure B. The electrostatic energy stored in the system B. Here energy stored in the system B we need to find out. So first of all, we will find out potential. What is V common potential? So C1 equals to C equals to 900 picofarad. V1 equals to 100 volt. C2 is 900 picofarad. V2 is 0. Find common potential because they are connected parallelly. That's why C1 is 900 into V100 plus C2 is 0 by 1800. 900. Okay. Then it becomes 2 zeros cancels out. 18 5s. 50 volts you will get. Then, okay, energy stored. Energy equals to U equals to half of Cp into V common square. Cp is how much? Cp means when two capacitors are connected in series, parallel, C1 plus C2. This is 1800 picofarad. 2 into 900 into 10 power minus 12 into 50 square. So 2 cancels out. 900 into 10 power minus 12 into 25 into 10 power 2. Okay. So This is going to become 25 nines are 25 nines are 225. Okay, 25 into 9, 225. This becomes 6 if it goes 10 power minus 6 joules. Okay, we will see nearer answer. Okay, here it is given that 225 to 10 power minus 6, 25 to 10 power 2, 900 picofarad, 900 picofarad. Energy as shown in figure in B, electrostatic energy stored in the system B. In this system, how much energy stored? That's given by 225 into 10 power minus 6 joules. Okay, maybe this point, this is 225, I think. So C option you are going to get. Okay, 10 power 4. Yes, 225 into 10 power minus 6 you are going to get. Right. Next problem. Ah, this is also exactly the same problem. See here, two capacitors are there. One is 10 picofarad, 20 picofarad charged to or charged to 200 volts and 100 volts. If they are connected by a wire, what is the common potential difference? That means they are connected like this. What is the common potential difference? You are going to get C1 V1, C2 V2. We know that common potential difference is given by C1 V1 plus C2 V2 by C1 plus C2. Okay, C1 V1, what is C1? 10 picofarad. Okay, let it be. Finally, picos will be cancelled out. 10 into V1 is 200 plus 20 into 100. Okay, denominator capacitances 10 plus 20. This is going to become 2000 plus 2000, 4000 by 30. You are going to get 1 by this 400 by 3. Okay, that will be what 33.33 volts you are going to get. That's nothing but option B. See, direct formula. Now, no, okay, nothing to think here. Just direct formula and substitute. Okay, you will end up with the result. Go for next problem. Okay, what is the electric potential at a distance 9 centimeter from 3 nanocoulomb? See here, we will have 3 nanocoulomb. Here we need to find out at a distance of 9 centimeter, potential is to be determined. We know that potential due to a point charge is given by 1 by 4 pi epsilon q by r. This is 9 into 10 power 9 into charge is 3 into 10 power minus 9 divided by distance is 9 centimeter, 9 into 10 power minus 2. 9 cancels out. This will be cancelled out. Okay, 300 volts you are going to get. 300 volts. Direct formula here also. Next one. See here. Voltmeter reads 4 volts when connected to a parallel plate capacitor with air as dielectric medium. Meaning is, if you have a capacitor like this, air medium. Okay, here if you connect a voltmeter, okay, you will read 4 volt. Let's say this is V0, air medium. When dielectric slab is introduced between the same configuration, same capacitor, dielectric medium is kept, K. Okay, voltage becomes 2 volts, V in medium. Okay, what is the dielectric constant K? We need to find out. Okay, we know that as dielectric medium is introduced, between plates of a capacitor, potential decreases as V equals to V naught by K. This is how it will be decreased. V naught is K, it is in the absence of dielectric medium. V is in the presence of dielectric medium. K equals to V naught by V. V naught is 4, V is 2. So that's why it will be 2. K will be 2. Okay, K is 2. Next here, a parallel plate capacitor is charged and isolated. Charged and isolated means separated. Isolation means separation. The effect of increasing the plate separation on charge, potential, and capacitance. Let's say if this is the case, if I increase the plate's capacitance, if I bring the plates to this position, this is D, this is D dash. Okay, as capacitor is isolated, meaning is battery is not connected. That's what isolation means. So no way charges can flow. Charges will not flow. Hence, charge remains same. Charge remains same. Okay, na? Charges remains the same. Next, think of the potential and capacitor, right? We know that, okay, charge remains the same, no? Even though distance is increased. You know that as C equals to epsilon naught A by D. As D increases, C has to decrease, no? Capacitance decreases. Okay. So as capacitance is decreased, okay, C equals to Q by V. As C decreases, V increases. Potential increases. Check that. Charge remains constant. Potential increases. Capacitance decreases. So this is how you have to think. Means here plate capacity is separated. That's why charges can neither enter nor exist. Okay, because battery is not connected to that. That's why it will now, okay, charge remains the same. As distance is increased, we know that C is nothing but epsilon naught A by D. As D increases, C decreases. As C decreases, V automatically increases. Okay, that's how we can able to think this particular problem. Next, go for it. A spherical shell of radius 10 centimeter. Radius is 10 centimeter. Okay, radius will be 10 centimeter. Then what we have to get? And is carrying a charge of Q over the surface. Okay, na? If electrostatic potential at 5, 10, 15 centimeter or V1, V2, V3, we have to check. Before that, let me draw this graph. Electric potential inside the sphere and on the surface, it remains constant for a sphere. This is many times we discussed. First, we will see that at this point, okay, 5 centimeter V1, okay, and another point here, this one, 10 centimeter V2, okay, after that 15 centimeter V3. See here, whether it is 5 centimeter and 10 centimeter lies inside or on surface will have same potential. Will have same potential. That's why V1 equals to V2. Whereas V3 is less than V1, that's equals to V2. Outside potential decreases. Okay, hence check now. V1 V equals to V2, which is greater than V3. Now go for next problem. A nature of equipotential surface for a point charge is, for a point charge, see, if it is a point charge, nature of equipotential surface is this. See, wherever you take, potential remains same. Concentric spheres is an equipotential surface. Okay, ellipsoidal with force I know, sphere with a charge at the center of the sphere. That's what. Next, go for it. System of two capacitors of capacitance 2 and 4 microfarad are connected in series. See, here we will have 2 microfarad, 4 microfarad are connected in series across 6 volts battery. Okay, the electric charge and energy stored in the system. See, to find electric charge, find the total capacitance. We know that Q equals to C into V. C effective into V. C effective equals to, they are in series, C1 C2 by C1 plus C2. 2 into 4 by 2 plus 4. This becomes 8 by 6. 4 by 3. Okay, microfarad. And V is 6 volts. No? Charge Q equals to CS into V. CS is how much? 4 by 3 micro into 6. 3 2s 8 microcoulomb. 8 microcoulomb. And energy stored, half of CS C effective into V square. Okay, so half of C effective is nothing but 4 by 3 microfarad into V square, 36 you will get. Okay, so 2 2s 3 9s 9 2s 18 microjoules. Okay, so 18 sorry 9 into CV square, half of C. C effective is nothing but C effective. This is nothing but 4 by 3 microfarad into V square. V is 36. 36 2s can 9 2s 18, 2 2s 3. Okay, 1s 3 2s 12. Sorry, 12. 12 2s 24. This will be 24 microjoules. So 8 microcoulomb and 24 microjoules. What we did here is they are asked to find total charge and total energy of the system. Total charge means total potential into total capacitance gives you total charge. And overall system's energy. Energy is half of C effective into V square. This is also some logical question. See, 2 point charges A and B are separated by a distance of 5 centimeter. This is 1 nanocoulomb. This is 3 nanocoulomb, 5 centimeter. Okay, it will have its own energy. Work done to move B towards A by 1 centimeter. Means A will be here only. Let's say this is B dash. Okay, we are to here 1 centimeter. Then it becomes 4 centimeter. What is the work done? We know that work done equals to charge into potential difference. Potential difference. That is, charge is, okay, Q1 work done to move charge B. That means Q at B into potential at B minus potential at B dash. Okay, or B dash and B. This is nothing but 1 into 10 power minus 9 into potential at B dash 1 by 4 pi epsilon naught Q at A is nothing but 3 nanocoulomb by 4 into 10 power minus 2 minus 1 by 4 pi epsilon naught K. This will be 3 nanocoulomb divided by K 5 into 10 power minus 2. This is going to become this will be 10 power minus 9 into nano, and this cancels out. 9 3s are 27 by 4 into 10 power 2 minus this becomes 9 into 3 27 by 5 into 10 power 2. Okay, so simplify this further. This is going to become, okay, this is 27 into 10 power minus 9, okay, into 10 power 2, okay, or 27 into 10 power minus 9, 10 power minus 9 is there, 10 power 2 is removed, 27 is removed, 1 by 4, 4 and 5, okay, 5 minus 1. This is 20, okay, 20 means this 5, okay, 4, 5 into 4, 20, 20, 27 into 2 into 10 power minus 8. This is going to become 54 into 10 power minus 8 joules. Okay, let us check that. No, this will be somewhere. We have chosen this. This 3, I think 9 3s are 27. 27 is removed. 1 by 4, 1 by 5, 5 minus 4, 1. 5 4s are 20, 20, 5s are 5. Here we missed 5. 5s are 5, no? Okay, 5 7s are 27 into 5. 5 7s are 35. 3 carry. 5 2s are 10. 3 30. So 135. 1.35 into 10 power minus 7, minus 6 is there. 1.35 into 10 power minus 7. This is going to become 9 only. Why it is 8? Here it is simplified now. Yes, it is 9. So 1.35 into 10 power minus 7 joules. So here this will be the correct answer, B. So only thing is, work done means charge into potential difference. That's all. Charge into potential difference gives you the work done. Electrostatic work done is given by charge into potential difference. Okay, work out that. Next, go for it. It is very easy. The minimum value of effective capacitance that can be obtained by combining three capacitors 1, 2, and 4 picofarads is. Remember that minimum value is obtained. Minimum value is obtained by connecting them in series. Maximum value is obtained by connecting them in parallel. Okay, na? If it is connected in series, 1 by C1 plus 1 by C2 plus 1 by C3 is nothing but 1 by CS. You connect them 1 plus 1 by 1 by 1 by 2 1 by 4. 1 by CS will be equals to 4 will be LCM. 4 1, okay, 4 plus 2 plus 1, 7 by 4 picofarad. Our CS will be equals to 4 by 7 picofarad. That's it. It was the 7 by 4 by 7. Okay, that's all. Another one. Is also based on conservation of energy. See here, mass of 1 kg carrying a charge of 2 coulomb is accelerated by 1 volt. Meaning is, if you have a capacitor plate, let's say it is grounded, it is 1 volt. If I keep a charge here, it's attracted towards this negative plate. It's attracted towards this. Negative potential attracts this. Attracts means it accelerated. Accelerated means potential and the charge. Okay, this is nothing but work done. Accelerated velocity acquired by the particle. Okay, when charge is accelerated, work is done on the system or on the charge. That's equal to, okay, gain in kinetic energy. That's equals to gain in kinetic energy of the particle. So work done is Q into V, that's equals to half mv square. Right? So Q is how much? 2 coulombs into potential 1, that's equals to half into 1 kg into V square. See, 2 to the 4 equals to V square, V equals to 2 meter per second. Right? Work done will appear as kinetic energy according to work energy theorem. So based on that, we can able to do, okay, this particular problem, and if it is simplified, you will end up with the result of 2 meter per second. Next one, see this problem. This is also simple one. Remember that if the problems are of this type, whenever you are going to come across 4 capacitors or 4 resistors, sorry, 5 capacitors or 5 resistors, better you to convert that into Wheatstone bridge. Better you to convert that into Wheatstone bridge. That's what. Let us say I'm going to convert this into Wheatstone bridge. How it is to be converted? Let's identify this as, okay, P, and this point as Q point. And let me rewrite this as like this. A 4. This is 4. Let's see. Let's go through it. I'm going to connect this here. This is P, this is Q. From there only, 2 more capacitors. Here this point is B, B kept as it is. See, is there any change in this? No change in the circuit. Everything will be same. See, this, this B is the junction of these 2 capacitors, and these 2 ends, see, end points of this capacitor and end point of this capacitor connected to P and Q only. This is also connected to P and Q only. That's why I can able to rewrite this. This is Wheatstone bridge and balanced. So presence of 4 microfarad between P and Q is, okay, neglected. So what happens to this? A capacitor, P, Q, P, R. So this becomes equals to, this will be 2, 2. because CS equals to C1 C2 by C1 plus C2. 4 into 4 by 4 plus 4. Okay, 16 by 8 is 2 microfarad. CAB equals to C1 plus C2. 2 plus 2 equals to 4 microfarad. Okay, this is the okay, right. Next one. This is very easy. See here. Work done to move charge on the equipotential surface is always zero. Why? Because if this is the equipotential surface, potential at A point, let's say B point, okay, let's say at C point, potential at A equals to potential at B equals to potential at C. So work done equals to charge into VB minus VA. That's equals to charge, let's say Q equals to 10 microcoulomb. 10 microcoulomb. Potential at B minus potential at A equal to 0. As potential at B equals to potential at A. Work done over equipotential surface is 0. Okay, right. Next one. So for this problem, two capacitors are connected in series. 3 micro and 6 micro. No problem if it is connected interchangeably because they are connected in series. They are connected in series with 900-volt battery. This is the first part. They are disconnected and reconnected in parallel. Potential difference across the combination. V common potential we need to find. That's it. C1 V1, C2 V2. See here, when it is charged as 6 microfarad and 3 microfarad are in series, charge remains the same. Remains same on both capacitors. Okay, hence Q equals to C1 V1 equals to C2 V2. Okay, that's equals to 6 micro into 300 volt. That's equals to 3 micro into 600 volt. So here 600 volts, here 300 volts. Okay, now V common equals to C1 V1 plus C2 V2 by C1 plus C2. That's nothing but go through it. C1 is what? C1 is 6 microfarad into 300 plus C2 is C2 will be 3 microfarad. Okay, this is 3 microfarad into 600 volts divided by this will be 6 microfarad plus 3 microfarad. How much you will get? 1800 plus 1800, 3600 divided by 9. This becomes 400 volts. Okay. So how much you are going to get here? This will be common potential will be 400 volts. See, first what we are doing here is we are charging the capacitors, both the capacitors by connecting them in series. Then we are disconnecting them. They are once again connected in parallel. We are finding the common potential difference. This is what we are doing. Okay, so this is found to be equals to 400 volts. Now, next move on to the next question. Two metal plates are separated by 2 centimeter. Let's say we will have two metal plates separated by distance of 2 centimeter and potentials are 10 and plus. This is minus 10 volt. This will be plus 30 volts. Let's say this is V1. This is V2. Then electric field between them. See, electric field equals to minus dV by dx, okay, or minus of V2 minus V1 by, okay, x2 minus x1. It's nothing but minus of 30 minus of my, okay, or minus 10 minus 30 by 2 into 10 power minus 2, or this is minus of minus 30 minus 10, sorry, plus 30 minus of minus, okay, whatever it may be, modulus you take, modulus of it, okay, so 30 plus 10 by 2 into 10 power minus 2, 40 into 40 into 10 power 2 by 2, 20, so 200, so 40 by 2, 20 into, ah, 20 into 2, uh, 20 into 100 will be 2000 volt per meter. This will be the case. See, this is just, we are given that distance and potential. That's why if you want to find out E, you have to think of E equals to minus dV by dx. Okay. So, but this is generally V2 minus V1 by kx2 minus x1. Okay, na? General formula. V2, higher potential minus lower potential. Higher, okay, will be this, lower will be this. Okay, adds, okay, definitely if it is 30 minus of minus 10 by 2 into 10 power minus 2, you will end up with 2000 volt per meter. Okay, and sign is neglected. That's it. Okay, right. This is how you can do. When potentials and distances are given, you can think of this formula. Next one is, see that this is also a little bit confusing. Don't confuse this. You rewrite this as like this. You keep it as it is, 50 picofarad, 100 picofarad, A as it is, A, right? A as it is. B, you take this as like this. That's also 50 picofarad. That's it. So these two are in series. So B 50 pico, then 100. Okay, series means CS equals to C1 C2 by C1 plus C2. 100 into 100 by 200. 100 to this is becomes 50 picofarad. 50. Then this will be 50. So this becomes B50. This becomes 100 picofarad. This is A. Cp equals to C1 plus C2. 50 plus 50. That's equals to 100 picofarad. So CAB equals to C1 C2 by C1 plus C2. 100 into 50 by 150. 3 is 100 by 3 picofarad. Okay, like this. So we just observe the diagram. Here it appears that all of them are in parallel, but not. So by just mere observation, we can conclude that what are the capacitors which are connected in parallel and what are all the capacitors which are connected in series. You can get to know. Okay. Then we'll have next question is, this is also logical one, not a difficult one. In the diagram, it shows that there are 3 points A, B, and C in the region of uniform electric field. Line AB is perpendicular to BC, E is parallel to the field lines. Then which of the following holds good? VA, VB, VC represents electric potential at A, B, and C. See, electric field means electric potential is work done in bringing unit positive charge from infinity to given point against the field. Let's say if this is infinity point, we need to move up to this VC, up to this VB, okay, up to this VA, okay. A and B are on same vertical line. VA equals to VC, VA equals to VB. But C is closer to reference point. Hence, VC is small. See, work done to move from infinity to C is less compared to infinity to B and infinity to A. A and B, of course, they are on the equipotential plane. Hence, VA equals to VB, which is greater than VC. Option D you are going to get. Okay. Then, here if we get the question like this, 8 drops of mercury equal radius combines to form a bigger drop. Capacitance of the bigger drop as compared to each smaller drop is. See, here we have 8 drops combines to form a bigger drop. Okay, very big drop. What happens to the capacitance? Okay, but if you don't know the shortcut relation, you need to simplify by taking radius, then capacitance and so. But we know that capacitance of bigger drop is equal to n to the power of 1/3 times capacitance of smaller drop. Capacitance of bigger drop equals to n is how much here? 8. N equals to 8 here. 8 to the power of 1/3 times C. 8 means 2 to the power of 2 cube, 2 cube whole to the power of 1/3 C. So cube and cube root cancels out 2C. That means capacitance will be twice, 2 times. Bigger drop will have capacitance twice that of smaller drop. That's what. Next problem. The next one is, let's see, we will see some problems. I will share the problem. Next to see, if you are given a problem like this, let's say you will have one plate, this is X, and this will be the another plate Y extended, and you are asked to find out capacitance between X and Y. X and Y. See, this problem, this type of problems might appear, okay, because nowadays we are getting this type of problems. Okay, each plate will have area A and distance between the plates is D. Now we see if this is the case, how it is to be identified. Let's say this is connected to positive terminal of the battery and this is connected to negative terminal of the battery. How they will respond? See here, they will respond like this. X is connected to positive, Y is connected to negative. Here positive charges will be stored over the surface. Here also positive charges will be stored. Here negative charges will be induced. Here negative charges will be stored because it is connected to negative terminal. Here positive charges were induced. Here positive charges were induced. So here there will be a formation of one capacitor. Here there will be a formation of second capacitor. Here there will be a formation of third capacitor. But how they are connected, we don't know. Okay. Here also charges will be stored, no doubt. Some other charges. We are not bothered. Now this can be solved by method called plate numbering method. Let us say I'm going to assume this as plate number 1. This has 1 dash. 1 is of no use because here we don't have any other plate. That's why those charges are of no use. 1, plate number 1 dash, 2, 2 dash, 3, 3 dash, 4. 4 dash is of no use. Check it now. I will start from X. From X, I have one plate. What is that? 1 dash. Between 1 dash and 2, you have one capacitor, no? 1 dash and 2, 1 dash and 2, this one capacitor is connected. Between 2 and 2 dash, see, this is 2 dash and 3, 1 dash and 2, we are connected on capacitor. 2 dash and 3, 2 dash and 2 are joined anyway. This is 2 dash. 2 dash and 3, we have one capacitor. 2 dash and 3. 2 dash and 3. This is what I have written. 3. 3 is connected to where? Remember that this is connected to Y. Y. 3. See? 3 and 3 dash are joined to Y only. 3 and 3 dash. 3 dash is this. 3 dash and 4 plate. This is 4. 4. But 4 is connected to junction of 2 and 2 dash. Junction of 2 and 2 dash. That's it. This is what the capacitor. Now you see this. These two are in parallel. That's why I can connect this as 2C. This is C. Because Cp equals to C1 plus C2. And now Cxy equals to C1 C2 by C1 plus C2. That is C into 2C by C plus 2C. That's nothing but 2 by 3C or 2 by 3 epsilon naught A by D. Like this. We are going to simplify this particular plate numbering method problems. These are the different type of problems we are going to get for CET or CET type related examinations. Okay, see, we are solved many number of problems like this. Okay, we are out of that. Okay, this is there are different methods. This is one of the method. I'll show you similar type of method. One more method. One more. Okay, one more problem. Let us say we have 3 plates like this, and 2 more plates like this. You are connected. This is X. This is Y. So if it is connected to positive, if it's connected to negative, see, positive plates will be stored, positive charges stored here, negative charges will be stored here. Here positive, here negative, positive only, here negative, here negative, here positive. How many capacitors are there? 1, 2, 3, 4. How they are connected? All of them are in parallel. Why? Because see, from X, how many plates? See, this is one plate, one plate. This is here, 2 more plates are connected. Okay, other joined, of course. This is different plates. No, it is equivalent to 2 plates, upper and lower. Both will have positive charges. This is positive, this is positive, this is positive, and this is also positive. Here see, this one, 1, 2, 2 dash, 3, 3 dash, 4, 4 dash, 5. What are connected? 1 is connected. 3, 3 dash, 1, 3, 3 dash, 1, 3 dash, and 5 are connected to positive terminal. See, 1, 3, 3 dash, 5. 4 plates are connected. Here see, between 1 and 2, 1 capacitor, 2 dash and 3, 2 dash and 3, 2 dash and 3, 1 more capacitor, 3 dash and 4, one more capacitor, and 4 dash and 5, one more capacitor. All are negative connected to negative terminal. See why? All are in parallel, 1, 2, 3, 4. So capacitance will be 4C or 4 into epsilon naught A by D you are going to get. Like this. Like this, we can able to connect, successfully simplify the problems. So like that, we'll have different oriented, but different type of problems will be there. You must be in a position to simplify that by using basic ideas of physics. Okay, like this. Okay, this is what one more type. If you want to have another type, we'll have different type of problems. I will show you one more, last one. Let's say we'll have, okay, these are in previous, okay, new. Okay, if you have three capacitors like this, if it is connected like this, okay, I told you, no, okay, all are of equal capacitance. Let's say, how many capacitors are here? There are five capacitors. Whenever you are going to get five capacitors, you must think of Wheatstone network. Let's see how it is going to be reduced. Let's say this is A point, junctions identify, B point, C point, D point. From X, this is A point. From A, there are two capacitors. See, one is A to C. This I have written A to C. A to B, this is going to write A to B. Let's say between B and C, I have one more capacitor. This I have written. Next, see, C to D, I have to have one capacitor. C to D. D is connected to Y, of course. And one more. This is over. This is remaining. B to D. B to D. See, all are of equal capacitance. So this is Wheatstone network and it is balanced. Wheatstone network and balanced. So you can neglect capacitor in between C and D, in between C and D, so that upper AC from A to C, one capacitor which is connected like this. Okay, these two are in series. Okay, the C by 2 you'll get, here you'll get C by 2. Finally, C across A, B is nothing but C. Okay, option is C you are going to get finally. Like this. C will be the effective capacitance of capacitors connected in this particular fashion. Okay, whenever the circuit contains 5 capacitors, 90% of the cases it reduces to Wheatstone bridge or Wheatstone network, and that too balanced. When once it is balanced, okay, you can able to simplify the things in an easy way. Okay. Okay, guys. Okay, thanks for hearing up to this. Okay, meet you again if possible. So if you have any clarifications on this, okay, you are free to ask me, right? Okay, do you have any clarifications on this? If you
Sir,
have
there are no questions now.
any questions?
No, sir. As of now, there are no questions.
Okay, thank you.
Sir, we are done with the session, sir.
Yes, sir.
Sir, I think some question came. Okay. Thank you, sir. Okay, sir. Then we'll end the session now.
Yes, sir.
Okay. Also, students, I will be sharing you the weekly schedule. Sir, please share me the PPTs which you solved in the class in these sessions, and also the PDFs of notes and contents from your side for the students.
Sir, shall I send it in this, Learnodaya 3.0 the WhatsApp group?
Yes, sir. It's fine. You can share it there, sir.
Yes, sir. Yes, sir.
Okay.
I'll do it within 2 minutes. Thank you.
Okay. Okay, sir. All right, sir. Thank you, sir. Thank you so much, sir.
Thank you, sir. Welcome, sir. Welcome,
Yes,
sir.
sir.
Thank you.
Students, tomorrow you have chemistry by Priyanka ma'am. So it will also have 4 hours. As I got a suggestion from one of our student, she wanted like 2 hours physics and 2 hours other class. So we'll look into it. I'll talk to sir once. If it's possible, we'll do that from next week. This week we'll let it go like that only. All right. So be on time tomorrow, and I want more number of attendees. These are very less number of attendees. Why like that? Are the sessions not interesting, or you guys are feeling bored, or you don't find it useful? You are just like it's free of cost. Nothing will be there in the session. So please don't think like that. These are only for your benefits, not for us. We have already passed out our degrees and all, and we don't want these teachings. It's only for you, not for us. We are only looking forward for your benefits, not for our benefits. So please be attentive in the class, attend lectures on time, be in the session. We'll make sure everything goes well. By end of the 30 days, I'll be proud and guaranteed that yeah, these people were there in the session and they can score good marks. So please be on time, be attentive. Tell your friends also to join the class, or either do group studies, project it somewhere, and everyone can take the benefits of these sessions. So please do that. I'll appreciate all those things. All right, so we'll end the session.
Time. The time proves that we have come a long way to get where we are today. Dayanand Sagar University, with the legacy of 6 decades, had contrived to the achievements today and is throwing light on the way forward. Our visionaries understood the need to learn and know, to do and grow, to twiddle and tweak, creating the best of the thinkers, creators, innovators, and inventors. In fact, we believe in achieving more than ever before, instilling the commitment to strive continuously to serve the national and global needs. There are challenges we can't ignore, but remember, we are of humankind, and every objective is achievable by setting our minds, and Dayanand Sagar molds you to achieve the objectives in an environment that enhances creativity and innovation. If we all embrace the spirit that there really is no limit, if we rise to this occasion and come together cross nations, if we integrate and ideate, we can make the future great and live the dream. Our legacy of education takes its root from our founding father, late Sri Dayanand Sagar, a visionary, an educationist, a powerhouse of knowledge and a believer in transforming the world, besides a leader par excellence. The institution has contributed to educating the world for over 60 years, carefully building alumni of over 100,000, including accomplished professionals, sports personalities, celebrities spread across the globe. We stand strong as a top-rated university, having 4 campuses with 350 teaching staff, educating 4,400 students with pride-filled and powerful alumni network across the globe. Dedicated faculty members who work across disciplines, collaborating and lifting us as the top university in the world, empowering the rising generation and nurturing entrepreneurs. Dayanand Sagar University. Live the dream.
Okay, guys, so you can leave the session now. We'll meet tomorrow again at 4 o'clock. Tomorrow you have chemistry. I'll share the weekly schedule in the group in meanwhile. So please go through the weekly schedule also. Accordingly, you can see for biology classes, mathematics classes also. All right. See you tomorrow. Bye.